Welcome everyone to the Tech Poutine pre-show for episode 18. This is, I don't know, I was going into this one thinking, how much is there to talk about? And actually stuff just dropped in the last half hour that we have to talk about. Yeah. Not only that, we're also, prepping for next week. George and I are going to be on site. George, next week, I need to reach out to Adam and see if we can do it in the PC World studio.
That would be cool. If we could do a Poutine nice. at the PC World studio.
At the PC World, yeah. And we'll have Adam or whoever to join us as well. Though, can we fit 3 people around that table?
I don't know how big that table is, so no comment.
Yeah. Yeah, so it is Tuesday. Is it the 11th, February the 11th?
Yes, it's the 11th. It's Tuesday.
Yeah, Tuesday.
Even though it doesn't feel like Tuesday.
I don't even know what day of the week it is. We're in that cycle now where there is news every day, mostly political, and you've got to choose with. I was having this discussion earlier, right? What late night show hosts do you watch, if any?
None, because I just can't anymore.
No, I mean, or have done in the past, even in a regular, irregular basis. If anybody's got their favorites, put them down in the comments.
That's okay. Not it. Actually, Jon Stewart at one point in time, but I really can't. I can't watch it without just without crawling up, without wanting to crawl into a corner and just cry.
It's it depends how busy I am, but I tend to watch either Seth Meyers or Stephen Colbert. The reason why it came up is because we've been doing some shorts on the channel, and we recorded one, and which should go up live in the next couple of days, about Linus being on Jimmy Fallon. But if we learned anything over the past 8 years, there is time you want to tune into that stuff because of the news of the day, and there's times you don't. And when it's political, bang, bang, bang. I say that, and I'm going to be the absolute hypocrite because in our to talk about list today, we're going to speak about some. It's because tech and politics are becoming a bit more intertwined these days due to corporate. I would
more geopolitical interests, honestly.
It's Silicon sovereignty is the name of the game. So yeah, we've got a couple of reviews to go through with you from George and his team. We previewed one and told you to go read it last week if you tuned in right at the end. So we're going to go through that. We're talking about some GPU stuff. We're actually planned this episode out properly, I think. Now we've got discussion questions.
This isn't just spur of the moment shock horror.
The thing we won't touch upon is that technically Arrow Lake H was launched yesterday. My machine should have arrived last week, but it's actually going to arrive Wednesday or tomorrow now. I got the message from DHL saying, yes, it'll arrive tomorrow.
So I pinged Asus about the Flow Z13 because I know that I won't be here basically from Friday until next Sunday. I won't be home. So
maybe that's what we should have pitched to Anthony. Oh wait, we could have done an 8-hour live benchmarking stream.
That would be fun
at the Asus offices. Though that being said, we'd have to miss a day of our conference next week to do that.
True, which would suck.
Yeah, I mean, it's as part of today's episode, we're going to go through this conference that George and I are going to be at next week. as well. So yeah, I think there's maybe one day that might, I don't know, a day worth missing. The thing is, do I fill it with an 8-hour live stream or do I fill it with actual meetings?
Fun or work? Pick one.
But work is fun.
Hey,
No,
I never said that work can't be fun. Just that I would argue that this may be more fun.
Pro Skiller. What do you mean they started exactly on time? We always start on time.
We've been pretty good about that in the past.
Because we stream to my LinkedIn, the TechPotato YouTube, the TechPotato Twitch, and to my Twitter. LinkedIn is actually a bit of a fuddy-duddy. If you can't start an event that was scheduled in the past, so we have to be on time.
Huh. Interesting.
So if you miss the start time, I'm not sure if it allows you to start the event properly. And let's just say I haven't taken that risk yet. That being said, you know, thank you to everybody on LinkedIn who does watch. We sometimes get a few every episode. Proskiller says, "Sorry, I'm used to other live streams where 30 minutes late is on time." Yeah,
yeah.
We have friends who do that, so don't worry.
Yeah.
Well, hey, we're on time. We just can never guarantee a day or a time.
Or if our sound works.
No. Sound's been good the last few episodes. Ever since ever since I bought the microphones.
Okay. Yeah.
We a few episodes ago, or actually it was just before Christmas, wasn't it?
It was October.
Just before Supercomputing, yeah. I bought Shure MV7s for both me and George to use. And to be honest, it's great for meetings as well and stuff. It's add on top of that the natural way that it picks up noise, and the system that we use a service called StreamYard. Their voice cancellation is actually pretty good as well. You know, it cancels out George's aircon at least. And Side Ranger says the mics are spot on. Perfect. Now, if only my internet was fast enough. Which allows
Ian issue.
Where? Which is actually there's an update on that. I can't remember if I've actually mentioned it on a Poutine or not. Because where I live in London, you know, it's Zone 3 London, which is pretty close in. My internet speed is 80 down, 20 up because there is no fiber. And I can move a mile away and get fiber, you know, gigabit symmetric equivalent. So I've been consistently checking the official OpenReach website about when my area is going to get fiber. It has changed in the last few weeks, such that they will be putting fiber in my street by the end of December 26.
Okay.
So instead of it being 2036 plus, which was the previous, it is now within the next 2 years, and it's being upgraded to 1600 down, 110 up, which is 5x up what I'm got. It's not perfect, obviously.
Whereas for my house, I can get 5G for $100. So 5G up and down for $100.
5 gig. No,
5 gig. Sorry. Yeah, 5 gig up and down for $100.
It's and to all the people asking, can you use Starlink? The upload is roughly the same as what I have now, plus weather. Could I not use 5G or bonded 5G? Yes, but that's just a pain. I did have an offer to get gigabit symmetric put in for the cost of £15,000, but that included a 3-year contract. So, and my video editor Dom, who lives in the arse end of nowhere on the south coast, in a village almost near a town, almost near a city, he can get like 2 gig symmetric for 50 quid a month or something stupid. And so the number of times I've just said, the video's done, can you just export it and upload it for the channel for me? And he's like, yeah, sure. Or though if I edit a video quicker than the upload of the original footage to him, I have to export it myself. because otherwise it still takes too long. and then I AV1 encode it to upload it because it's a whole thing. I want to be done with it. So rant about slow internet speeds. I mean, I had better internet 20 years ago in dorms in my undergrad where it was 100. So
so if I went to my lab on campus and I went to the primary, so there was essentially a primary jack in one of the labs that I had access to. That was 10 gig. That was 10 gig up and down.
So you're limited by your computer's ability to decompress the files from Steam.
Yes.
Yes. Okay. Whereas when I went to university, we had issues because when we had LAN parties, they were in a building that didn't have internet, and we didn't have smartphones that we didn't have 3G data back then.
Yeah.
That's how old I am. So trying to sync everybody on the same Steam version so we could all play Counter-Strike was a pain.
Well, no, what's funny is so the lab in the CNS, or Center of Natural Sciences building, had 10G. The observatory, on the other hand, was still being run by
Pigeon.
No,
Pigeons carrying USB sticks.
56 by 56K.
Yeah.
56K modem. And in order to actually start the startup process, you literally had to access a bulletin board, BBS. That would have been 2017.
Diesel Phi End, or Diesel Fiend, depending on how you want to pronounce it, says we pay $90 a month for 500 megabit, which is way too much. I would crawl through broken glass to get 500 megabit right now. But yeah. My mother-in-law in Eastern Europe has essentially gigabit, and she pays $12 a month or something. So yeah, it's Eastern Europe has better internet than the UK, better than Germany. So it sounds like we're all good on the audio, we're all good on the video, things are working, lights are blinking. So let's get into the show properly. Let's change that banner up. And here we go. Welcome everybody to the Tech Poutine episode 18, your usually weekly, whatever day of the week we tend to run it, event where we get to speak about chips that we are interested in and silicon news. Unlike a lot of the other news, we like to just talk about what makes us happy and what's fun in the industry and what gets a reaction out of everybody else. This show is brought to you by George and I. We have no sponsors, so we are the sponsors, and we're going to shill you a bunch of our stuff. So please do like and subscribe. The question of the show is simply what makes a good poutine. So if you want to participate, please put in your ingredients for a perfect poutine. And maybe we'll have a question like that every episode to start. Topics we're going to cover today. It's George. Why don't you lead the topic headlines, or choose one that you want to do?
So, well, I guess starting with Battlemage. So,
let's just go through the topics of the episode.
So topics. So the first topic is going to be Battlemage. Then, looking at T-Head and P550 performance. These are both these topics are articles that we have written, or Chester has written on CNC, and we'll be looking at those along with some comments from me on the T-Head stuff, T-Head and P550 stuff. Following that, there's going to be a preview of ISSCC, which is a conference that both Ian and I will be at next week. Lots of fun stuff. ISSCC is usually a pretty good, very technical conference, which is fun.
Yeah.
Then Ian, I'll let you cover this one because I don't
yeah,
want to touch this with the
it's
1,000
like I
foot
say
pole.
that there's been a bunch of news that's happened today that we also want to go into, and just to list it off, Intel has gone up because of some stuff that was said by a vice president at the AI summit in France. Heads are changing at Intel, even though we kind of joked about the new Intel CEO on last week's Poutine. It turns out that one of their main characters is leaving to be a CEO somewhere else. Then we also have news from AI companies, one of which may be on its way out and disappearing, and one of which got a bunch of funding. And then I've got a note on the bottom here that says Muskie versus Sam Altman, and yeah, let's not go into that. So yeah, let's go with the first topic, which is Battlemage. Let me just share a screen here. Short and curlies, what is Battlemage?
So Battlemage is Intel's second generation of DGPU, so dedicated graphics. Their first generation, if you'll give me a quick second, just spin around.
Here's second gen. It turns out if you want to buy GPUs, these are available.
It depends on where you are. Here in the US, they've been selling out pretty well. So they've been selling pretty well. This is their first generation, codename Alchemist. This is the A750, which we compared to in this article. And this is essentially Intel's first or second generation of DGPU, and it's really their first time that they're really, pardon the pun, dedicating to dedicated graphics. In the past, they've done some attempts with like really early stuff, i740, and then we had the Larrabee stuff, but that didn't really pan out. i740 ended up becoming integrated graphics for Intel, and this is their first time that they're really sort of driving into the DGPU market. And let me just put this over here. And yeah, it's honestly really good for $250, 12 gigs of VRAM, 4060 performance, give or take. Yeah, I honestly, I quite like it.
I saw a, I've seen a few videos recently where they've spoken about, for example, NVIDIA's reluctance to go cheap. So will there be a 5050, for example, this gen? Will there, won't there? Will there be a 9050 from AMD? Will they, won't they? That sort of class, that sort of price point. So the fact that Intel's doing it at this price. Now, Battlemage is XE2 architecture, which we have already seen on Lunar Lake, technically. However, this is the card is the B580, which came out in December. So it sounds like a mid-range because it's the 5 series, not the 7 series. I've got a discussion question later saying are bigger chips coming? So let's leave it for that. But is this the card you guys were using? The
yes, this is the Steel Legend. It's
so
honestly
that's ASRock.
Yeah, that's ASRock. Honestly, that cooler is complete overkill for the card.
I know
but
it's the
it does
2
run
8 pins.
very quiet, which is nice.
That's that's 2 8 pins. That's 600 watts, isn't it? 675 if you include the PCIe connector.
Well, no, it would be 375 because each 8 pin is 150.
Okay.
EPS is 300.
Okay.
Which is what you might be getting confused on. And funny thing, 6-pin is 75 watts, even though both the 6-pin and 8-pin PCIe power connectors have 3 power pins and 3 ground pins. Anyway, but back to Battlemage.
So this article is a system architecture analysis.
Yes.
So
we're looking at we look at the microarchitecture, and we look at essentially what's changed between Alchemist and Battlemage. And so this is the block diagram. This is essentially your high level. Well, what does it look like if you?
This is Alchemist. No,
this is Battlemage.
Yeah.
So this is essentially what, at a high level, the B580 looks like.
It kind of looks like the NVIDIA diagrams we always see.
That is what Chester was going after in this design of that diagram. Yes.
Are we all tending towards the same sort of thing? But I mean, most people are familiar with Intel parlance, so they're streaming multiprocessors, CUDA cores.
Yes.
What the Intel names here? Render slices, XE cores.
The comparison for NVIDIA, the render slice actually, if you he doesn't have it for these. So the XE core is the closest analogy to an SM, or streaming multiprocessor. Each of those has 8.
Some cache.
Each of those has 8 XVEs.
Yeah.
Which has 8 512-bit vector engines. Basically, the XE core is an SM. The XVEs are SMSPs, or streaming multiprocessor sub-partition, I believe, in NVIDIA parlance. And then those vector engines are your ALUs, or your CUDA cores, essentially. CUDA cores are 32-bit, is essentially an FP32 ALU. So each subpartition has 16 CUDA cores, or FP32 ALUs.
So yeah, there's a lot of stuff going on. So
yeah, unfortunately, parlance in GPU terms is kind of confusing.
Yeah. So okay, let's just stick with XE second gen then.
Yeah. So XE second gen, XE core. This is very much a beefed up version of Alchemist, but with many changes. And I think the single biggest one here is 64-bit atomic ops. A big sort of weak spot for Alchemist was the lack of 64-bit integer operations in hardware, which meant that actually accessing blocks of more than 4 gigabytes of RAM was very slow, which is a problem. Which is a problem when you have a big GPU with 16 gigs of RAM and you want to access, say, a 8 gig chunk. That's why they've added 64-bit atomic operations, even though FP64 is not used very often, or in 64 either.
So even though 64-bit isn't really relevant for playing games, if you do have a chunk of memory that is more than 4 gig, you need 64-bit support for the memory addresses.
It's the same thing as when we moved from 32-bit to 64-bit in back in the early 2000s, right?
Yeah, but I'm just making the delineation that it's not used in the game per se for rendering graphics, but it is for memory accessing for the graphics.
Yes.
Perfect. Yeah.
So yeah.
And just in this case, if people don't know what an atomic operation is, it means it's a guaranteed operation. For example, a read, modify, write. If you read a bit of memory, modify it, and you want to write it back, you need to make sure that the memory that you've just read hasn't changed in that time. So what atomic operations do is guarantee that when you write it back, you're writing it back to the same memory address that had the same value, and nothing else can access it until the operation is complete. It's atomic because essentially it's a one and done. Normally, all these things run asynchronously, so you could have 2 threads modifying the same address. And because reading and writing and modifying take time, You don't want somebody to go in and change a value that you weren't expecting. Atomicity ensures that, but you need hardware support for it.
And sort of the other big change here is that they are now running what they're calling native SIMD16 engines. So each of those XVEs are running. So the way that you push instructions in a GPU is you push essentially to a SMSP or an XVE or a WGP in AMD's parlance. And previously, Intel was essentially SIMD8 native, or their XVEs used 8 CUDA cores, and they would push essentially 8 instructions to those CUDA cores. Well, now it's fully native SIMD16.
So it reduces overhead, basically.
Yes, NVIDIA SIMD32 or warps in NVIDIA parlance. AMD is 64 with RDNA 3, and prior gens was 32 as well.
So when a GPU renders a scene, imagine you've got 1080p, that's 2 million pixels. So it might spawn 2 million threads per frame to do what it needs to do. It doesn't, but imagine that's the case. It obviously has to do that in batches. And what George is saying is now those batches are essentially batches of 16 rather than batches of 8. Yep. NVIDIA does batches of 32, and AMD, depending on the architecture, is 32 or 64. If you've got fewer if your thread count in a batch is higher, it means that you just have less overhead in terms of management, which saves a bit of memory, saves a bit of bandwidth.
And if you slow down,
just let me finish this point. If there's a conflict, though, there's more likely to be a conflict with larger groups of threads in that batch, and so the recovery time might be a bit higher. But that's the trade-off in design. If you imagine just a standard linear serial code on a CPU core, that's just a batch of one.
And if you scroll down a little bit, scroll down, there. That picture up one.
Wait, that one?
No, up one more.
Okay. What happens? This one.
Yes. So as you can see, the Alchemist is on the right, Battlemage is on the left, and as you can see, Alchemist is more complex with how it did its XVEs, because it was actually a pair, so that it could do SIMD16, but it wasn't fully native. Whereas with Battlemage, it is fully native. It is complete. It is fully unified. Looks a lot more like NVIDIA or an AMD architecture than Alchemist did.
But part of the difficulty Intel always had is that people who develop code for GPUs think of GPUs in a certain way. So if you produce something that's new, that's harder to program or more granular, it becomes more difficult. So this helps.
So, and something else that they've improved is co-issuing between the FP unit, the integer unit, and the XMAX unit. As you can see in the above diagram, those are on individual ports, and Intel has essentially improved the co-issuing of instructions to those units in Battlemage.
Yeah, support for integer 2 extensions. We've got this matrix unit as well. That's new.
No, it's not. It appears to be the same XMX unit as on Alchemist.
It's not showing it up here.
So it is, the dedicated DGPU Alchemist does in fact have XMX units.
Okay.
but yeah. So if you
Here are
want,
some. Explain this diagram that we're seeing.
so this diagram is basically where are you, what's filling up and when. This is showing what pipes are being used at what point, and as you can see, there's ALU0 and ALU1 for the pipelines, and then there's XMAX. Which what's interesting here is that VTune, which is Intel's profiling tool, has counters for ALU0 and ALU1 both active. You can see that at the bottom here. And ALU1 and XMX both active.
ALU0 and XMX. Just, yeah.
Yes,
I think there's a bit of typo there, but anyway.
Yes. Actually, the typo is on the left side. It should be ALU0 and XMX.
Yeah.
But what's interesting is that there's no ALU1 and XMX both active, which does imply that you have to issue an XMX unit, or you can only issue essentially an XMX instruction through ALU1, through the ALU1 pipe. And you can also have the ALU0 pipe active at the same time, which is interesting.
It's so I mean, just to give perspective here, if this graph looks really weird to you all, the first one is Intel's AI playground. So what we're doing here is stable diffusion. Let's generate an AI image. So we're going to have a bunch of XMX use cases here, just because that's what AI likes. On the bottom, we have Cyberpunk 2077 with XESS. That's the super sampling upscaling technology. And what the lines here are saying is how much of whatever part of the GPU is used. And you notice that it's never it's very rarely 100%. Very rarely do you have all 100% of the transistors in your GPU twiddling at the same time. And that's just because of data structures, what needs to be computed, and the type of math being used. And these numbers come from, as George said, a software called VTune. And what this does is helps developers understand whether they're over issuing certain work into a certain area, and whether they can load balance or reduce power or reduce time, per frame, or in the first one per image generated. So it's all about performance and efficiency and trying to identify where the bottlenecks are in your design. So but in this case, for George and his team and for Chester, it's a good representation just to see what's being used where.
And if you actually go down to the next image, that actually shows the instructions by data type. So that one. This is essentially telling you what instructions are being issued at any one time. And as you can see for the XMX unit...
Wait a second. This is in specific workloads. So at the bottom, it shows Intel image generation, same thing again. Llama 7 billion. Cyberpunk is in purple. We've got a different AI image generation in light blue, and Baldur's Gate 3 in orange. So on the left-hand side, it shows you what type of instruction, and the graph.
At the bottom is basically what program's being run, and as you can see, I would like to highlight the int64 section of this. Even though this is occupying a very small part of the instructions here, if you didn't actually, if you weren't able to use int64 instructions, you would see a huge slowdown, because you would have to access your memory in chunks, which could be a huge slowdown. So even though no FP64 is being used, int64 absolutely is being used. And
so even though it's 0.05% in some of these applications, actually it's pretty big.
Yeah. And the other thing I would like to highlight here is that the only application here that's actually using the XMX unit's floating point capabilities is the AI playground image generation. However, the MMX units are being used for int8 to upscale Cyberpunk 2077 with XeSS using, like I said, int8. So it's a very small percentage of the instructions are int8, but again, if you didn't have that, potentially this workload could be a lot slower.
It's essentially those 1% of instructions are providing you with a lot of your performance when you're upscaling something like Cyberpunk. Which is, yeah. So, yeah, even though it looks like, 74% is still standard FP32, because that's what a lot of games run in, because that's just rendering. When you do the upscale, it's a fraction of the time, or a fraction of the number of instructions. It actually says nothing about execution time.
Yep.
But it just having the support is needed.
Yeah. And
so what I would like to see for that FP64, because they're all 0.00, is just add a few more decimal places there, because it might be 0003.
I don't think it actually lets, like, I don't think I think it's only 2 decimal point places in the
software you use.
Yeah. I don't think
in that case, you should just say just write the number in Paint. 4.
4 instructions
out of 200 billion.
But yeah.
Yeah.
So,
okay, so that's a pretty cool graph. You're not going to see that anywhere else, outside of our good friend Dr. Moritz Lehman, who actually works for Intel now.
So
but he programs in them. Good to see you, Moritz. Sorry, yes, keep going.
Oh, it's not here. Okay. I guess we didn't run it for whatever reason.
Let's keep going. This graph.
No, I say that because so Moritz.
I know.
Yeah,
it's all right. Let's just go over it.
This is just showing throughput. This graph is just showing essentially throughput of the GPU and FMAs and ads and.
So this is comparing previous gen Alchemist to Battlemage.
This is literally comparing the GPU that you saw in the title versus actually this GPU, this A750. So
So why is Alchemist ahead in most of these?
Because it's a bigger GPU. So that's the thing about Battlemage, is that it's actually in comparison a smaller GPU. This A750 has 28 Xe cores. Battlemage has 20, or the B580, excuse me. The B580 has 20.
So if we were to see a generational uplift, I mean, even with frequency differences, we would have to divide by the number of Xe cores.
Yes. Yeah, it's
FP32 FMA is way ahead. That's a good 50% right
so
there.
So we don't quite know why Alchemist was underperforming in that test. It should be about 20-ish% ahead, because the number of actual ALUs in an Xe core is still 128. That hasn't changed from Alchemist to Battlemage. So yeah, I don't quite know why that was a bit lower. It's just odd.
Yeah.
Odd behavior.
And then same thing with integer throughput rather than floating point.
Yes. And you can see that for integer 8, they've sped up a lot of instructions, which is very good to see.
So this is int 8 on the vector cores, not on the matrix cores, or is it on matrix?
This would be on the matrix core. Sorry, this would be on the vector cores. Excuse me.
Okay,
I'm pretty sure.
So yeah, cool. And then we have some memory accesses.
Actually, I'm going to eat my hat on that. I do apologize for that. The integer 8 The intraday numbers are actually on the matrix units. Let me eat my hat on that. I do apologize.
Okay. Yeah, no worries. So texture bandwidth.
So this is essentially accessing one of the fastest parts of the cache hierarchy, essentially. This is your texture cache. This is usually resident within your L1 if you don't have a separate one. But yeah, so this is usually your highest bandwidth or one of your highest bandwidth caches on a GPU. And yeah, even though this Alchemist, the A750, is a bigger GPU, Battlemage is putting up a very, very close fight here. Now, in this graph, what you're seeing is latency. And now...
Lower bar better.
Yes. Alchemist stops at 128 megabytes. I don't quite know why. Again, I think that might be a driver thing. Or
so Alchemist
thing.
So Alchemist in orange, for those who can't read it, Battlemage in blue.
Yep. And then
B blue, Battlemage, Intel.
Yeah. But yeah, what's interesting is that the memory latency does go higher than Alchemist. That could potentially be because of essentially kill B sizing. Because if you go down a little bit, there is a slightly different graph from a different set of tests. Yeah, there we go. It is a little bit odd. You would think Battlemage should be lower, and it likely is. Just this might be some TLB stuff. Just driver stuff. Yeah.
So there's a lot to go through here. L1 bandwidth, local memory, and just if you've never programmed different hardware before, in the land of GPUs, the same thing can be called many different
15 different things. Yeah.
So I had to deal with this almost 15 years ago. But the thing is, you've got so this is Intel native, AMD native, NVIDIA native. Then you've got OpenCL terminology and then Vulkan terminology layered on top. So whether you're doing native languages like PTX or CUDA or one API. One API,
one API.
OpenCL, which is trying to be everything to everyone, and Vulkan everything to everyone, has their own naming because they've got to find a relative medium, just to make it annoying.
There is one last graph I would like to point out. If you scroll basically near close to the bottom.
I mean, we'll let people go through this.
There. VRAM bandwidth spikes. So this is
what's the VRAM bandwidth spike?
So what this is showing is how much traffic is the VRAM having to service at its worst point in time, essentially. So this is how essentially what this is showing is how well is your cache to memory bandwidth ratio done, for lack of a better word. And
so what's important here is you want the biggest blue bar, which is your L2 bandwidth, and the smallest orange bar.
Not necessarily. What you want is to not see that orange number go above your VRAM bandwidth, or even get close to your VRAM bandwidth, which for Battlemage's case is 456 gigabytes per second. So and as you can see, the VRAM bandwidth is pretty well matched with the 18 megabytes of L2 capacity. So Intel did a really good job with matching the compute to cache to memory bandwidth ratio,
rather than having one of them bottleneck. Yeah.
Yep.
And this is across, again, AI workload, gaming workload, gaming benchmark,
and then RT.
Gaming workload with ray tracing.
So, but yeah, there's a bunch more info in the actual article. Clam did an excellent job with the write-up. So yeah, go check that out.
So yeah, the result is impressive, with Arc B550 easily outperforming the A770 despite lagging in nearly every on-paper specification, just because the core was redesigned for a better compute efficiency.
And I know you posted it earlier, but I posted a link to the article in the chat. So if you want to go check that out. Now, moving on.
How much is this card?
$250. Actually, that specific card was $270. Okay. And because we weren't sampled, big massive thank you to the Chips and Cheese Patreon members, and thank you for donating so that we could afford the B580 since we weren't sampled it.
Yeah. Okay. Now we got to the end of that. I've got some discussion questions for us to go through. Which because this is George and his team's article, I thought of some questions. Number one, is it any good? I think the answer is yes. Yes, that's a simple one. So given the performance uplift from Alchemist, is this evolution or revolution? Because it looked like the same building blocks, just differently arranged.
Yeah, it's evolution. It's heavy evolution, but it's evolution. It's very much a new architecture, but you very much can see that Battlemage is descended from Alchemist. So yeah. Personally, yeah.
So we've seen now this XE2 architecture on Lunar Lake and B580, but we haven't seen a big GPU. So does it make sense that this design could scale? As in, could we get a $500 card if they design the chip that way?
Could they? Sure. I'm almost certain that Intel could make a bigger GPU out of Battlemage. They've ironed out the biggest. I would argue that the single biggest issue to scaling was the lack of 64-bit atomic operations, and they've added those into Battlemage. So
they just have to decide that that's a market they want to go after.
Yes,
and have the wafer capacity to do so. Okay, so given that it's been a couple of months, 10 weeks since this card launched now, 8 weeks, and all the reviews were again positive about it because it's a new $250 card. It's great to have a card that price range now. Was the hype at launch justified?
Yes. And the reason why I think the hype, I think it's lived up to the hype because it's $250 for the specs that you're getting. I think it is a killer price to performance GPU.
Okay. So what price wouldn't it make sense? If it came out at $320.
That's rough. I think if it was any more than about $300 for the limited edition card, so the sort of stock card, I think you would have seen anything more than $300. I think it would have had a lot less of a good reception. I think $270 people would have been happy with it. $250, it got the hype that it did, and it
was the right part of the curve to.
If they had charged $350 for it, I think it would have been panned, and I'm glad that they didn't. Because I want a third player in the DGP market. Like, competition's good.
Yeah. So, I mean, it also depends whether they're actually making money. The revenue numbers for this fall under client, so we don't get a breakout of, excuse me, graphics. But you know, I thought graphics was dead anyway. Somebody keeps commenting. I thought graphics was dead.
It's all compute now. It's all AI.
Moore's law is alive. So, okay. So the other discussion question here: where does Intel go from here? Is it let's make bigger Battlemage, or let's go for the next gen, which I believe is called Cleric?
It's not Cleric. It's
Celestial. Sorry.
And then the one after that is Druid.
Yes. It's Cleric and Druid.
Yeah. No.
Maybe they're the same.
It's D&D days. Alchemist, Battlemage, it's D&D or TTRPG. But yeah. So if you want what the rumor mill has been saying, then supposedly the big die of Battlemage has been revived. What's known as, I believe, G31 has been revived. If you believe the rumor mill. Who knows? And again, if you believe the rumor mill, supposedly there will be no celestial DGPUs and that Druid has been pulled forward. Again, who knows? We'll find out. Maybe this is all wrong. Maybe it's all correct. Who knows?
So these are all made at TSMC, right?
Yes. Battlemage is TSMC N5 and Alchemist is N6. The die size for Alchemist is 406 millimeters squared, and the die size for Battlemage, if I remember correctly, is 272 millimeters squared on N5. So not a large die per se.
So back in 2021, when Intel made these names, I filled out the rest of the alphabet.
What do I think E will be?
No, so this is also me doing a little bit of shit posting because you have to. So Alchemist, Battlemage, Celestial, Druid, Excelsior, you know, Bit of Stanley, Fridge, Germany, Arc Germany, Hysteresis, Iron, Jamboree, Kiln, Lemony.
I see P.
Yeah, Manticore, Nunnery, Opulent, Potatoes, Quiescent, the Arc Quiescent, the Arc Realist, Arc Science, Arc Tantric, Arc Undulate, Arc Velocity. I like that one. Arc Weather. What else are you going to do with X-Ray, right? Arc Triple X, Arc Xylophone, no, Arc YOLO, and hang on.
So chat is saying Enchanter potentially for E, which makes sense.
Trademark, search our trademark database, trademark search system.
Are you actually searching trademark for Zune? Is it available?
For footwear? Zune is abandoned.
Oh, so it could be Zune if we ever get to Z. Arc Elder Taurus. That's funny. Arc Turtle?
So if anybody wants the trademark for Zune, it's either dead, cancelled, or abandoned. So this one's live. Mark. Wait. Mark information. So for cameras, earphones, telephones, adapter plugs, armbands, batteries, battery chargers, binoculars, bikes, nature art, non-motorized vehicles, family, education, cryptocurrency, electronic. Okay, so pretty much everything. So if you are Brian Frankel from in Maryland, he currently has when's the expiry? Is there an expiry? No, I guess you have to yeah. So no, you can't use Zune because somebody does have it.
Cry. No Zune for Intel.
Why does the name Brian Frankel? Yeah. If you want the funny one, and I really want to do a video on this.
Oh no.
So if where is it?
That one? The one above?
No, this one. This is the current owner is XAI. Where's the history? Okay. Can I search for company? Oh, yeah.
We're completely off track here at this point.
This one, yeah. I realized when I changed tabs, you guys can't see it.
This is all off screen. Yes.
AMG. I need to find where I saw it. Yeah, if you go look for trademarks owned by AMD.
Oh, I know what it was. It was the one. It was the Grok. The trademark Grok owned by AMD.
Yes.
Yeah.
AMD used to own the trademark Grok.
Yeah.
Funny, right? Yeah. There's a video I want to do about expired trademarks. Yeah. So. That was so yeah, Battlemage. Yeah, I did get off track there, but that's because I wanted to search online for different alchemist names. So that is Battlemage. Let's go straight into our second topic. A RISC-V processor designed or used by Alibaba.
Yeah, so T-Head's owned by Alibaba, so you could say designed by Alibaba.
Yeah. Can you pronounce this one?
So T-Head Xuantie?
Xuantie.
Xuantie?
Yep.
The C910.
C910.
So, yeah, so the C910 core from T-Head. This is a RISC-V processor, or RISC-V core, and okay. So right off the bat, I have to disagree with this slide because it says RISC-V RV64GCV. Now, for y'all who aren't in the know, what that means is RISC-V 64-bit. G just means general, which is a whole set of essentially other ISAs combined into one nice letter. C meaning compressed, so that's a compressed instruction set to make the 4-bit or 4-byte, instructions 2-byte instructions to save space in the instruction caches. And then V stands for vector. However, I disagree that this has RISC-V vector support because it's not 1.0. It's 0.7.1 support. And that has caused issues with testing.
So I'll preface this by saying this slide is from 2010.
2020.
2020, sorry. We are now in 2025.
Yes.
So things have changed in the world of RISC-V in 5 years.
Yes.
I mean, I'm not saying RISC-V as a whole can be slow, but things have definitely changed in 5 years.
Yes.
So, they did a initial announcement / deep dive on the architecture at Hot Chips 2020. So it's taken you 5 years to get hold of this chip, George.
Oh no, we've had this chip for, I want to say 3 years, but it's yeah, this has been a long time coming in terms of an article. But yeah.
And so this is the high performance RISC-V core from 2020.
Yeah, so David LT in the chat says it doesn't have it. It's not version 0.7.1. It is based on it.
It's a fork.
It's yeah, I disagree with the fact that the slide has V on it.
So the reason why it's taken 3 years for George and team to get this out is because they be issues, yo.
Yeah. It's also not very stable as a platform, which is a problem. A funny little bug with this thing is that it keeps changing the IP address because the Macs aren't stable.
Is that just your system, or is that due to the...
No, that's like, apparently this has a bug in the BIOS or the firmware that, yeah, this is very...
Okay, so yeah. Let's go through what you've got.
So what's very nice is that this diagram is actually from the Alibaba paper. The stuff on the red is descriptions added by Chester. But the very nice diagram from Alibaba is basically saying where what things are. So like where the instruction fetch unit is, where the integer units are. Honestly, a very nice little diagram of where things are.
So what would you do with this sort of diagram? Or is it just, hey, this is cool?
Hey, this is cool. Like, just, yeah. Because
that's why you all tune in to Potato and Poutine and cheese.
Well, right. So usually all it is just logic blobs, and you can't really tell anything. Yeah. Intel and AMD are a little bit different because they do have hand designed blocks. So you can sort of tell what things are. But for a lot of ARM chips, a lot of RISC-V chips, it's essentially the computer generates it. Use case for AI that you've talked about in the past. But a computer just puts the logic blobs wherever it thinks is most optimal.
So this chip targets AI, edge, industrial, and ADAS.
Yes, this core targets that.
Oh, so this is a core that may go into different things, but it's already been up. It's already been superseded anyway.
Yeah, it's been superseded by the C920 and then the C920 V2, which, if I remember correctly, the C920 either has RISC-V vector 1.0 support, or the V2 does, and the V1 has 0.9 support. It's weird. Yes.
David LT in the comments has all the info.
Yeah.
It's used in a softgo chip.
Wow.
George has had experience with softgo.
Well, not just that. Unfortunately, softgo is forbidden from using TSMC because they were shipping 7nm chips to Huawei. So yeah.
But anyway. T-head can use TSMC.
Yes, T-head still can. And this chip is actually made on TSMC 12nm. And it runs at 1.848 gigahertz.
Okay.
I'm just going to call it 1.85 or 1.8 from now on.
Yeah.
But yeah. What was really nice is that in this paper they actually gave static voltages.
Nice.
Yeah, that's what's interesting, is that the characteristics that the paper is saying is low power, low area, but what the marketing slides and the slides from Hot Chips were saying was
AI.
High performance and AI, which, yeah, they don't quite go together.
Marketing, engineering, marketing,
yeah,
engineering, analyst.
Yeah. But yeah, so scrolling down to the core overview, this is the 12-stage pipeline of the core. So that means it takes essentially 12 cycles for it to complete through an instruction, essentially.
And you're comparing it here to an ARM A73.
Yes, because both A73 and C910, actually, I'm gonna have to hold my tongue there. A73 is a 2-wide design, whereas C910 is a 3-wide design, but they are both similar in their design goals, so to speak. So that's why that comparison was made. Also, comparisons were made to the P550 core from SiFive, which is another RISC-V.
We'll get into that in a second. Yeah.
But yeah, what's really nice is that what's known as Verilog code, or the not the RTL, but the Verilog code that builds the RTL is actually open source. This core is open sourced for the most part. Some of it, like the vector unit, actually is not open source, but that is where Clam has essentially deconstructed that code and has done an excellent write-up of all the stuff that we usually can't necessarily tell from external micro benchmarking. So
sort of how many SRAM banks and arrays.
And some of this you can assume, but
it means you end up with graphs like this.
Yep. Oh, that's pretty cool. Very big core, very big diagram. If you scroll down a little bit more.
Wait, hang on. Why does this say which way? Isn't that a decoder? No, that's a decoder.
No, that's crossbar.
Yeah, okay.
And then which
goes into the instruction buffer.
Yeah, the joke is, which way does the crossbar go?
Oh, okay. It goes every way.
Yeah. But yeah, if you scroll down, and then here's the branch prediction resources. You very rarely get to see this. And actually, if you go down one more graph,
Mode predictor.
Yep. Here's the very pretty pattern recognition graph. What this is showing is basically how many branches can the branch predictor track, depending on how dense the number of branches essentially in an array are.
So do you do this on the actual silicon, or is this using like a?
No. This runs on this is a micro benchmark that runs on the actual silicon.
Okay.
Yeah. So it's actually pretty comparable to the branch predictor found in A73. Yeah, which is really cool. The BTB, or the branch taken buffer, has 1024 entries with a 4-cycle latency. What's interesting is that in a lot of cores like these, what you'll see is the BTB is actually tied with the instruction cache. So if you have, say, a branch per 4 bytes, you'll be able to see up to, in a 64K cache, what would that be off the top of my head? That's not 1024. A branch per 32 bytes is going to be, you're going to see 2048 entries. But for this core, it's actually not tied, which is more common in high performance processors like Zen 5, or like most x86 modern x86 processors, most modern ARM cores. They're what's known as a separate BTB unit.
Mm-hmm. I do want to bring up this question because, given what we just said about the Verilog, if the Verilog is open source, does everybody try to throw it on an FPGA?
Maybe. Actually,
You haven't,
honestly, probably very likely somebody has thrown it onto an FPGA. We haven't. We don't have an FPGA that one is big enough, or two even have an FPGA at all. So we haven't tried it, but presumably you could throw this onto an FPGA.
I think we have to get our contacts. Well, hang on. I wonder how many transistors is it? The core. Tens of millions?
No, this is going to be like at most probably about, say, 100 million, 200 million.
Okay, so 800
like
million
that.
800 million gates. Yeah. You still need a big FPGA, but
I think don't quote me on that. I don't know how many transistors this has. It may be more, it may be less. I don't know. But yeah, this is the decoders. This decode section.
Again, you can, because of the Verilog, you can see that there's one long split decoder and 3 short split decoders, and they share a main. So when Intel says it has a complex and a simple decoder, interesting. We never see this.
If you scroll down one, you can see all the micro op formats, which is a big long list of how it all renames the decoded instructions. And this is a very long, especially the one on the right, it's very long.
So when you do a complex instruction, it'll essentially decode it into several of these. Most modern cores do it. Most instructions are decoded 1-to-1.
Yep.
There is some odd stuff that'll do more than that.
Division is a big one. Division is usually not one op. It's usually more than that. Isn't
the term cracking? You're cracking an op into several micro ops.
Yeah, you crack the op, but usually you crack the op into a single op, which is weird to say, but yeah.
Though beyond that, sometimes you can do op fusion.
Yep.
Of the micro ops. So
a common one for that is like essentially an add and then a jump. So if you add a number and then jump to a different stuff like that. And then so this graph is showing the instruction fetch bandwidth of the C910 core against the P550.
The SiFive.
So the P550 core is another RISC-V CPU from did I say SiFive? RISC-V processor from SiFive, which is one of the big RISC-V development houses. Now, in here you can see the ROB buff, the ROB or the reorder buffer. This is essentially how many instructions or ops can the processor keep in flight.
We often talk about ROB size, reorder buffer size. So 181 instructions ain't bad.
Actually, it's probably likely 192, which puts it on par with Haswell from 2013.
For context, most modern cores are around the 300 to 400 range, except Apple, which is more like 600.
Apple's weird. Apple's weird.
I know it's weird.
I'll just leave it there.
It's usually highlighted as one of the big things that it enables it to extract performance. However, depending on what you're running, it's asymptotic race to performance, and it still costs power.
Yeah, it's weird. But yeah,
that's George's official stance on the matter. Weird.
Yeah, it's weird. It's weird, man. But yeah. Moving on to the execution units.
So this is integer, and Chester's comparing it to a Goldmont Plus and a P550.
Yes. Because Goldmont Plus is forever. But yes, if you're wondering what that 10R3W means, that means that there's 10 read ports and 3 write ports. So it can read from essentially 10 registers and then write to 3.
Yeah. Which again is something we don't normally see in a chip design. And your point about vector support, that looks like a very small vector.
So yeah, the vector side is actually also shared with the floating point. So the floating point and FP register file appear to be shared, which is similar to x86. Some other, like SiFive's P870 core, actually has a completely independent vector unit with its own register file. This actually shares a vector and FP register file.
But this is interesting. This is something I definitely understand. How many cycles it takes to do a floating point add, multiply, or a fused multiply add. Some recent cores can do it with 2 cycle latency.
Yep.
The fact that the C910 is doing it at 3, which is again the same as the A73, it just falls down a little bit on the multiply. So gives and takes from the P550.
What's interesting is that the P550, it appears to just use the same unit for adds, multiplies, and FMAs. So there's no like fast path, whereas C910 does have a fast path for adds and for multiplies, and A73 also has a faster fast path for multiplies.
Yeah. But it's also, you balance how many cycles versus what the power of the core is meant to be. So low power cores also tend to take longer just because it's more power efficient at the end of the day as well with their resources. This is the load store unit.
Yep.
I realize we're getting into an hour on these 2 articles.
Oh, yeah.
So I think let's
again,
there's a ton of stuff here. We're only halfway through the article, people.
Yeah. So this I would like to highlight.
This?
So if you could, so this is essentially how well does the load and store unit forward data or deal with like crossing memory access boundaries? How well does it deal with cache alignment, stuff like that? And C910 actually handles this for a low power core pretty well. It's within reason. It's roughly about you get about a 20 cycle crossing penalty if you have a failed store forwarding result. Not great, but not bad. Whereas
it's about the same level as AMD's pile driver,
which honestly, pretty good place to be. Unlike the SiFive P550, the P550 can take over 1,000 cycles if it fails to store and align access.
I realize
if you have anything unaligned, a load is 1,000 cycles and a store is like 800, and they can't actually be done in parallel. So if you have an unaligned load and then an unaligned store, that's 1,800 cycles down the drain, which is not great. The reason for that is,
how often does that happen in code, really, though?
So,
or is it just edge case?
So, what architecture are you talking about? And what compiler are you talking about? And what compiler optimizations are you talking about?
Basically, you just have to perform well everywhere. Just in case.
So,
you can afford those massive drops in performance if your thing is in a well-contained box that nobody else can use, i.e. a microcontroller in a big GPU.
So
and then we
and
go
yeah.
into some caches.
And the last thing I would like to highlight, if you scroll down to the table, yeah, here we go, is the read bandwidth for all the cores. So
is this a sum?
Yes, this is essentially a sum of all the cores accessing read memory, essentially trying to read from memory. And yeah, the C910 sort of just falls on its face.
Yeah.
Don't
use the memory.
Yeah, don't use the memory for the C910. The P550 does pretty well there compared to the rest of them. But yeah,
but only if it's aligned. Only if your operations are aligned.
But yeah, it does. So the C910 does struggle with using all of its resources efficiently, and that's actually the next thing I would like to get to. There are some images in the document. The first one. So So a little bit of background on this. Spec is an industry standard benchmark. Spec has had multiple iterations, of which the newest iteration is 2017. And there's it's a whole bunch of subtests that is broken up into two categories.
Okay, yep, here we go.
Yeah, it's broken up into two categories: integer tests and floating point tests. And this chart is showing the performance of, so this chart's actually not in that article.
Okay.
This is something that I've been wanting to talk about, but I haven't been able to write this video yet. So I'm going to talk about it here. And this is how a company kind of shoots itself in the foot. And I'll explain why I say that. So here are the Spec 2017 scores. And on the left is the SiFive P550, which scores 1.17 and 1.29 in the integer and FP scores, respectively. Now, I'll compare it real quickly to the A73, which is running at 2.2 gigahertz versus the 1.4 for the P550. The A73 is a lot quicker because of the clock speed. But it's not just that. Now, SiFive says that the P550 core is 30% more performant than the Cortex A75. So not the A73, but the A75, which is the newer version of A73. Mm-hmm. Essentially, it's the successor to A73.
I assume that's a comment ISO frequency.
Yes. So if you go to the next graph, now what this graph is showing,
this one.
No, the Zen 5 one.
Okay, this one.
Yep. So because you can't really set clock speed, what I did in order to ISO the clock, which is bad and you shouldn't do this, is just do a simple clock division, which is literally just divide the clock of the thing that you're normalizing to. So 1.4 gigahertz in this case, which is the speed of the SiFive, to the speed of the A73 or whatever core you're comparing, which is 2.2 gigahertz. Now, I have this graph here to show that this is actually
if you try to scale from 1.4 to 5.7, you would get results of 23, for example, in the FP. In reality, the result is 19, so you overestimate.
Yes, or actually in this case, what you're doing is you're actually underestimating the performance when you're comparing to the lowest clocking CPU.
Yeah.
Because you're essentially, what happens is that a slower clocking CPU doesn't access memory as often, so is better fed.
The reason is so sometimes in your chip you're waiting for things, and if you're running at a slower clock, those things, access to the memory is still at 3.2 2 gigatransfers per second or
Mhm.
whatever. That hasn't changed, even if your core clock has changed.
Yes.
So the reason why I'm a fan of testing at stock performance is because when these chips ship, they ship with the right combination of CPU frequency and DRAM frequency that the vendor has defined as being the right rate, or at least a good ratio. The minute you start playing with that, the minute you say, here are 5 cores or 5 chips all at 3 gigahertz, you've actually nerfed some and made some others better because you're now got a different amounts of latency for different workloads. Now, I'll put my hand on my heart. When I was younger in this industry, I did that for, when I did early, 2nd, 3rd, 4th, 5th, 6th gen core comparisons, I used to test them at ISO frequency, still JDEC memory, but it means that if you try and do we sometimes see it as score per megahertz or score per gigahertz sort of thing. And again, it's a comparison isn't linear. That's basically the takeaway. Scaling isn't linear with frequency. And you can see this. You can go run a benchmark at 1 gigahertz, 1.1, 1.2, 1.3, and just scale throughout. And the graph isn't straight. The graph eventually asymptotes.
Yeah.
Right?
So,
because other things become bottlenecks.
But yeah, the reason why this is there is to show that, right? To give you a visual representation. That's what happened. Now this final chart here, this is essentially doing a simple clock division to get ISO clock, like the ISO clock performance. Not really, but it's the best. It goes to show my point. And as you can see, the P550 is matching the A73 clock for clock. Now this A73 is the implementation found on the AM Logic S922X, and implementation does matter. And the SiFive P550 is the S1 EIC 7700X. And
so it's not a MediaTek chip or anything, for example.
There was supposed to
it depends on the process node, and
so this is actually on TSMC. They're actually on equivalent TSMC nodes, if I remember correctly.
Okay. But again, implementation matters.
Both on 16 nanometer or 12 nanometer, one of the two. So there was supposed to be a implementation of the P550 found in the Horse Creek SoC that was supposed to be fabricated by Intel. However, that fell through, and that design was supposed to clock to up to 2.2 gigahertz on Intel 4 nanometer. Intel 4. Now I say that because 2.2 gigahertz is not particularly quick, even for a low power chip nowadays. The A73 on a much older TSMC node is clocking to 2.2. The Intel Goldmont Plus is clocking to 2.7, and then there's FX, which usually sits at 4+ gigahertz, right? But if you look at these numbers, this ISO clock comparison, it's roughly matching A73. And and the S1, in my opinion, is actually a pretty good implementation of P550, in my opinion. There's nothing that looks egregious and goes, no, this looks terrible. It's a decent enough implementation. I don't see where they're getting A75 plus 30% performance, or A75 plus 30% performance here. And
well, I mean, we're talking mostly about the T-head in this section, and just to see it that far down.
Yeah, and even though the T-head in many respects is actually a bigger core than P550, it does actually perform worse because it just isn't using its resources as efficiently as P550. But yeah, I guess this is sort of my soapbox, and I struggle. I don't like it when companies say A75 plus 30%, and you go and you test it, and it's A73, arguably minus 5% because
it's like saying apples taste great. Well, what apple? And what color and where is it grown and what soil
Yeah.
is it and what did
So
it's a headline for anything else. But before we get into the discussion questions, I wanted to highlight a couple of other things that I'd seen, just because it's RISC-V based. I'm not sure if I showed you this, George, but this is Occamy.
I have read it.
So this is Pulp. This was another 2020 Hot Chips presentation. So the same as the C910, except this one has HBM on it.
Mm-hmm. 2 HBM stacks.
Yeah. Do you notice that this package has divots in that remarkably look like Intel high-end desktop package size?
Oh God, did they reuse it?
I don't know. They actually have a custom interposer here.
Actually, you know what this chip reminds me of? The original MN Core stuff.
Yes,
because it's that same shape, right?
But this is 432 RISC-V cores of their own design using HBM2E, Synopsys RAM bus. This is what one of the cores look like, and this is what the interposer looks like, built on Global Foundries. They actually said that because of their presentation of Hot Chips, the whole process was sped up because people got in touch and said, let's accelerate this. Let's do this. So, academic chip. That's pretty cool. I'll stick this link in the chat as well in case people want to go see it. And there's details on this design as well. But that's cool. RISC-V chip with HBM. I mean, that's not a GPU. The compute is RISC-V, not the control is RISC-V. It's going to be years, I think, before. May it be years before we see that intense torrent? Cool. And the other thing I wanted to showcase, again, because I simply did a short on it yesterday, which is going to come out next week, I think, is that you can now get for your framework. Now, I do not have an investment in framework. I'll put that right up front. If people get that joke, good for you. So the framework is a modular notebook where you can buy a chassis, you can buy a screen, you buy the I/O, and you buy the main board. And now they have a RISC-V main board using a SiFive GH7110 processor, which is 4 SiFive U74 cores, which is around A53 performance. So this is a quad A53, which is, for perspective, a low-end phone from 2014. Because I had one, and I did a review on it on an Antec. But this is made by DeepComputing, which also made the first ever RISC-V notebook. And I was actually speaking to the CEO of DeepComputing today on LinkedIn. We ping each other once a month about something, but we've never actually been in the same location. He moved from London, I think, to the US, and now he's moved to Switzerland. He never seems to stay in the same place for that long. But I haven't approached him and said, "Hey, can we have a look at your notebook or whatever?" But no, we're having a chat because seeing if we can get together. But yeah, this is RISC-V main board. What else did I have in my notes here? The thing is, it does only have 8 gigs of memory, and that's fixed on boards. That's not unchangeable. It's $200 for the main board.
So,
is that the right price?
No.
Or £169. Is that too expensive?
That's too expensive. So I put a link to another board. This board by Milk-V. It actually uses the exact same S-Win processor as the development P550 board. And that's also $200 for 16 gigs of RAM and a much more capable processor. So unfortunately, it is sold out right now. But that's a desktop. Part of what you're paying for is the modularity into the framework design to do it. But For a development board, I would argue that a desktop
It's not
light board is
Yeah, I know, but
better.
if you want a notebook that's RISC-V, it's either that or get DeepComputing's DC Roma 2, which costs 2,500.
Or you SSH into a dev board
What if you're
that
in the
you
air?
own at home.
Yeah.
I guess, but like,
Solid Reactor has a question here based on what we were talking about earlier. If you were to downclock from stock to half and then test the performance, take that result and double it, would that indicate what the stock could perform at higher memory speed? No, because there are other things inside the core where you're waiting on stuff. Yeah, it's when you've got your queues and your reorders and your buffers, and things will fill and unfill at different rates based on your frequency, and that you can't really model properly. Okay, I do have some general discussion questions from your article.
Mm-hmm.
Let's just go back to this and bring it up. So, discussion questions. RISC-V for general purpose computing. Where are we? Still waiting.
We still have a while to go, in my opinion.
So what's the limitation here? Is it hardware or is it software?
Right now, it's both. Honestly, it's probably more hardware than it is software. One of the big issues, in my opinion, is that currently, right now, as of the time of this filming, and I hope that Tenstorrent can help with this, there's no high-performance out-of-order core for RISC-V that also supports vector. A lot of the RISC-V Vector 1.0 supporting cores are in order, or they're like the C910, which has the performance of an in-order core in many respects. It is not particularly competent. The issue is, and David says C910 and P550 are old designs too. Yes, they are.
That was my discussion point. you preempted.
Dang it.
So to that point, we first saw the C910 in 2020 and the P550 in 21. Why are there so many delays in announcing IP to getting it in the hands of somebody like you? I mean, you said you've sat on this for 3 years, so maybe that's a wrong question.
We've actually had the C910 system for a while. Just it's been a pain. Maybe not 3 years, maybe like 2 years, but it's just.
This is the presentation from in Hot Chips, so
it's been quite a rough experience with the system. The P550's been more polished.
So is that just a case over time we're getting polish?
Yeah. But the P550 system, at least the dev kit that SiFive has, does have some issues. Like they cheaped out on the core VRM, and they chose a fixed voltage regulator, so you can't actually clock it to 1.8 gigahertz. But on the NPU side, they put a very nice monolithic power systems VRM, but they didn't put that on the CPU side. So the NPU that doesn't have software support great.
Anyway, could you change it manually?
No. Yeah, I would. Yes, but I would literally have to go solder stuff onto the board.
Well, hang on, because I've got the dev board here.
Yeah.
The CPU is on its own little carrier board, right?
Yes.
Could they not just create a carrier board with better components and sell it to you?
Yes, but in my opinion, this is the development board. This should be the best it should be, or the best that it can be. But it's not. That Milk V board that I linked earlier is actually arguably a better board in half the price. So,
I
I
don't have a screwdriver to hand, but yeah, no, this is, you can maybe see there's a carrier thing here. Maybe I'll, if I go big, you can see it says, turn it around, HiFive Premier P550.
SiFive Hi5 Premier P550. Actually,
Yeah.
So speaking of the name of this, Tom's Hardware did a review just before ours and misnamed it the HiFive Premier P550, not the SiFive Hi5 Premier P550.
I like it that the fans from a company called Coolsville.
Yes.
Totally rad, bro. If
yeah.
I had a screwdriver, I'd take this off and see what's in
Do you have your lttstore.com screwdriver on hand?
No, it's in a box somewhere. Okay, so that's those are our two main topics that we want to go through. So this is a point in the show where we're going to speak about sponsors, and as I said at the top of the show, this show doesn't have sponsors, so we're sponsoring it. So George, plug your stuff.
Chips and cheese. We have videos too. There's a I haven't uploaded a video in a while. It's because, well,
He's writing it. He told you.
Yeah, well, this has been the video that I've wanted to make, and I've been struggling with it.
Everybody has to give George encouragement.
Yeah, it's yeah. Yeah. But
so,
go read our stuff. Our stuff is great. Chester's amazing at writing. And
George is amazing at videos. So
I wish I was better. I wish I could write it quicker, but yeah.
Yeah. It's you'll get there. So for my stuff, obviously you're on the TechTechPotato channel. I do have a Substack, more-more.com. I also have an online store where I don't have a mug, I don't have my t-shirt, but what I do have now, and I can show these because these came in, is stickers.
Oh, stickers.
Pins are on the way. So if you head over to shop.techtechpotato.com, you find stuff there. I recently put in a new item that I think might be interesting for everyone.
I really should. People have been asking for CNC merch.
So it's right. I'll get you set up with the people I use. But this is what happens when you go to the store. The biggest seller by far is the wafer scale Cerebrus potato on a mug. It's a decent size mug. I also recently got myself one of these long fitted potato t-shirts. They're pretty good as well. And then you get obviously the field of potato and then just the regular potato on a mug. And there's Jeff from Craft Computing with a TechTechPotato mug. The new thing here is the D0 or die hoodie. So if you know anything about designing chips and foundry and the metrics needed, D0 is the defect rate and die is silicon. So D0 or die, which kind of looks like do or die, because obviously, yes, this is, lovingly AI generated, of course. Available in all sorts of sizes and colors that I thought made sense. This is something I'm going to work on going forward to help drive the channel. Get some, more designs, more of the channel designs as well. But no, I'm really liking the long fitted t-shirt. As somebody who doesn't wear that many long sleeve t-shirts, it's nice and comfortable. For sure, and I have too many mugs. I've been told to stop buying mugs. So
I have that same issue too. I have too many mugs.
And I also wanted to highlight in this sponsor section that Tomorrow, I have a premiere of an interview I did at the Lattice DevCon event with one of the Lattice executives about why FPGAs are now more in vogue than ever before. And the title isn't facetious. Your AI supercomputer wouldn't work without these. They do more than compute. They also do security, quantum quantum secure crypto, that sort of stuff, and also management features and all the good stuff that FPGAs do. That's gonna premiere tomorrow, 5 p.m. UK, 9 a.m. Pacific. So I'll be hanging out in chat with that. If anybody who wants to watch, that was a really interesting interview because the guy who I did it with, Issam Ilashwani, he was interim CEO between, so he's still in the C-suite now, but because he's been in the FPGA industry for a long time, he's seen the ups and downs, and now with the fast rate of AI, everything's changing. So if you ever want to have a look into that side of the business, we always talk about CPUs, GPUs, and ASICs. FPGAs are the other side, and Lattice is one of the top 3 companies to do that. So come hang out with me tomorrow with that, and also ask questions, and I'll see what I can provide. So let's go into the second half of the show, and the second half will be shorter than the first half. George and I want to speak about this. ISSCC, the International Solid State Circuits Conference. It's one of the 3 main IEEE conferences a year that I focus on. Is Hot Chips an IEEE event? It isn't, is it?
Yes, it is.
Okay, so one of the 4. There's Hot Chips, there's IEDM, there's ISSCC, and there's VLSI. And I've got a number of interesting things is happening at this event. Now, this document here is, I can drop a link to it, but as you might see, it's 106 pages, and it's all this weird long format because that's how they give it at the event. It's a technical conference about solid state circuits. It's all about circuits. So the important thing to, I think, put out here is these are the main events. What we have in, at the beginning is educational, so stuff for students. And then we have paper sessions. Now, each of these, you're right there, George.
Yes.
You're ruffling papers.
Oh,
it's very echoey.
So because I'm old school, I actually printed out the advanced program on paper.
Oh,
but yes, I like marking stuff like this on paper personally. So
the point is that there is well over 250 talks, 250 papers being given, and a bunch of demos, and it's all stuff that's in research, anywhere between, actually, some of the stuff is launched already, and we'll get into some of that, but some of this stuff is like 5 years out from being public. So this is why I go to these shows, because you find out stuff before everybody else talks about it. And if stuff's good that we can package into content for the channel, I think we need to change the banner, Dom. Then we can present it to you guys as well. This is where, for those of you who saw the my phone is better than yours video, where I spoke about my MediaTek phone going all big cores. That some of the information from that video I got from last year's conference. That was a September video, I believe. And I'm going to share what my schedule looks like for this show, because I think mine and George's will align quite a lot here based on our interests. So George and I are going to be there. It's all next week, starting on the 16th. and we're gonna see if we can do a Tech Poutine in person, given that we're both in the same location. For those of you who are attending, say hello. But it is in San Francisco. Is it at the Marriott Marquis or is it at the Hilton? I always forget. It's one of the two.
The Marquis.
Yeah. Okay. So Sunday is an educational day where they have a forum. And the one that I'm interested in is to do with circuit techniques and new approaches for die-to-die links in chiplets. So everything... Go on.
Oh, no, I was just saying. And unfortunately, I'm going to miss all of this because I'm going to be on a flight from New Jersey.
So the funny thing is, technically, I don't have access to this day as either. Because they... Normally at these events, you get a press pass or an analyst pass, and it allows you to go to everything. For some reason, ISSCC does not allow press and analysts to go to the educational sections. So last year I arrived and was like, wait, why can't I go? And the answer was simply because you haven't paid for lunch. So I'll go sort out my own lunch. I just want to sit in the presentations. Turns out a forum, if you're not an IEEE, so if you want a full all access pass to everything during the conference, all the tutorials, all the forums, it's $1,500 if you're not an IEEE member. Just this one day, if you want it on its own, is $600, which is quite a lot. I'm not sure how much how well they pay the speakers or such. Yeah, I as Mr. Vipitis says, IEEE membership isn't that expensive. You get about a 25% discount, and if you're paying like $1,500 for the ticket, then the discount is worth your IEEE membership. So you can get it. You can get some money off. But yeah, if I can go to this, we've got Intel here talking about UCIe requirements and innovations, because we just had UCIe 3.1 announced, I believe.
That's the Excel 3.1. I think UCIe 2.0 has been announced.
There we go. And then we had, so here XCR means transceiver, D2D means die-to-die. And there's all different ways you can do die-to-die links. You can do single-ended, you can do double-ended, you can do high speed or low power, or in this case, this paper is looking at optical die-to-die links, which is something I've been interested in for a while as well. Then we have tools. Synopsys is going to talk about tools with chiplets, which is a big thing about how do you get, normally these software tools, you design a chip. But if you design a chip and then design a chip, there's no way for them to work together. So you need a system to do it. And then we have Cadence doing another die-to-die IP. Then we have more research. IMEC is going to talk about advanced packaging, what we have today and what's coming up. This may be well-trodden stuff for people who are very familiar with it. Especially if you've seen a couple of my big videos recently, where I've done presentations or panels speaking about packaging. This one's interesting and almost the old now. Mercedes is presenting in the session. Designing a chiplet-based SoC for automotive. Guess who's presenting that paper?
Please don't tell me it's Francois.
It's Francois.
Would you like to get people up to
our good friend Francois Pierre-Noël, formerly of Intel, now designs chips at Mercedes. So he will be there. I wonder if he'll speak to me or punch me. It's the sort of relationship we have. I don't know, time's passed a bit. And then we have some other things at the end of the day. But then we get into proper paper sessions. Day one, so proper day one, is the invited papers. Intel is going to speak about AI, which is something we've covered on this channel quite a bit. Samsung is going to talk about...
Originally, the presenter for that was supposed to be Pat.
Yes, it was.
And it's not Pat anymore.
It's not Pat anymore. Good point. Good point. And And then later we have Samsung talking about processing in memory. And then Infineon about semiconductors in software-defined vehicles. So, interesting thing there. In the afternoon, we have session 2, processors. So just for context, out of all the talks, out of the 250 plus talks, I've just condensed it down to the ones that I'm interested in. This afternoon, for example, I'm going to session 2. There's session 2, 3, 4, 5, 6, and 7. And they all have about 10 papers in each. I want to go to this one just because we've got AMD, speaking about Zen 5. That's probably going to be the same stuff that we've seen before.
No, actually, AMD's ISSCC papers are actually really good. Like their Zen 3 one talked about the different breakdowns of transistors. So what percentage of low VT transistors versus high VT versus mid VT versus low leakage. And then they talk about like layout stuff. AMD's papers are actually pretty good at ISSCC. So I'm looking forward to that. And then IBM has Telum 2, which is the successor to Telum. They covered Telum 2 at Hot Chips last year, so it'll be interesting to see what
high level.
Yeah, high level. And let's see what they're going to be talking about here. Intel's going to be talking about.
Well, hang on. They've got 2 talks about Telum, and the other one's
another
later
one about Z as well, if I remember correctly.
Oh yeah, no, yeah. But the Z and Telum are same thing. Super chat from Dragon Balls D. Yeah, love it. For just under $5. Thank you very much. Intel is talking about AI is like Helen Keller describing her favorite color.
I should laugh, but
yeah, I'm partially colorblind, so that doesn't help me either. What are you trying to say?
Wait, you're partially colorblind?
What are you trying to say, Balls? Is that if that is your real name? Okay, so after Town 2 we have Granite Rapids D. So that will be the edge optimized version of Granite Rapids. Why are you smiling?
Well, no. So you said that you were partly colorblind. Jeff from Craft Computing's also red green colorblind, and apparently Dom is also. I am not colorblind, so I just have bad eyes.
You're just regular blind.
Yes.
My eyesight's pretty good, and I'm knocking on the door of 40.
Oh no, my eyesight is terrible.
Yeah. So this one, it's actually 2.4. Intel 300 megabytes of SRAM at 20 terabits per second with scalable across 20 chiplets. I think that's a dev chip, or it's Falcon Shores.
My brain went to Ponte Vecchio.
That's 47.
On half of the die, yes. The other half.
Yeah, but this is ISSCC. It's all about the future. What is this nonsense?
Yes, but my brain went immediately to Ponte Vecchio, which could mean it's Falcon Shores.
Yeah, we could get some insight into Falcon. Intel's outreach regarding what they're presenting at IEEE conferences is minimal, and that's just it's not seen as a marketing thing. They do brief us at IEDM, or they brief me at least, because I know the guys, but this not so much. Yeah, so that's proper day 1. Day 2, the Tuesday, not much going on in the morning that I'm that interested in, but first thing at 8 o'clock is dynamic guard bands on IBM ZNext. So Telum 3, basically. I'm pretty sure this is Telum 3, not Telum 2.
Yes.
And given that, we've kind of already spoken to IBM, and ZNext has been in those roadmaps, is going to be interesting. And then after that is MediaTek's going to talk about runtime power management. with sensors and how they machine learning based calibration on a 3 nanometer chip. The Dimensity 9400 is still 4 nanometer, I believe.
The 9400?
Yeah.
Yeah, the 9400 is 4 nanometer. It's not 3.
Yeah. Yeah, so this is an unannounced chip. Mind you, it could 3 nanometer, 8 core. It could be something other than the smartphone. MediaTek's ASIC business. It could be the chip that they're making with NVIDIA for notebooks. Yeah.
Unlikely.
Unlikely, but we'll see. We'll see. We'll get to poster sessions in a second, Mr. Putis. So in the afternoon is the invited talks. So these are talks they've actually reached out to get. Broadcom is going to be talking about their new switch chip, Tomahawk 5, which is their 51.2 terabit per second network switch. FuriosaAI is going to talk about Renegade. We actually have some news about them later, but that's the chip they announced at Hot Chips. Samsung is going to talk about a generative AI NPU in a 4 nanometer flagship SoC. Which mobile chip would that be? I thought the S25 all went Galaxy. Snapdragon.
What was Exynos 2400 on?
5. Anyway, we'll see. And then Samba Nova here with their SN40L, which is their latest chip, again announced back at Hot Chips.
So Exynos 2400 is on 4 nanometer.
Okay. And then so Mr. Vivitis asked about post sessions. This is basically where the demos in the hall are going to be. There is a student research preview on day 1 that is going to be open to everyone. That's I think each student's going to get like 2 minutes on stage to talk about their research. Let's go to Wednesday. Wednesday's a very big day if you want to talk about SRAM and DRAM. I mean, this session here is all about let's make dense SRAM on new nodes like 2 nanometer gate all around and 18A, or it's about high density 3 nanometer designs with additional features like dual porting. We're actually doing some math here, and it sounds like Intel's high density SRAM is 25% more dense than TSMC's at the equivalent node.
No.
We've done the math between these two numbers. Because one's in megabit per square mil and the other one's in micron squared.
Yes, but if I remember correctly, it was still the 0.21 is equivalent to N3.
No, this is actually so if you convert this into megabit per square mil, it's 47.
Because that's the same density as TSMC N3. That's the same SRAM bit cell size.
So this could just be, hey, we've got it working. Not this is our densest version.
Well, no, if I remember correctly, that number converts to 0.019 or
No, 0.026. We did the prep on this. Anyway, we're going to go see what these are all about. MediaTek, again, with the ASIC design, is going to talk about their memory. 0.3 femtojoules per bit is quite interesting, and then we have some dual porting. In terms of DRAM, 400 layer TLC 3D NAND. So that's going to be fun. High-speed GDDR7. And then Samsung's also showing off called LPDDR5 Ultra Pro.
I can't wait to have my AMD Ryzen AI Max
Pro
Pro
Plus
395 plus with LPDDR5 Ultra Pro RAM.
In my
in my Dell.
in my Dell 13 Pro Premium Max.
Oh God. This is not insane.
It makes Intel Core 10th gen processor
seem banal.
Yeah. And you got to put your 7900 XTX inside. Yeah. And then also SK Hynix is showing 2 terabit QLC at 321 layer. I'm not sure whether this speed, 75 megabytes per second program throughput, is good or not. And then this is the only conflict I have in the week, and it's in the afternoon. It's between session 36 and session 37. We've got this talk down here, which is Telum 2 DTCO. So it's design technology optimization for power, performance, air, and reliability. Or it's the TSMC/AMD UCIe in 3 nanometer, which is their die-to-die connectivity.
Oh, dang. I hate that those overlap because I want to go to both of them.
I think we might have to divide and conquer that one.
Yeah. Because so for a little bit of context, that TSMC/AMD UCIe talk, AMD doesn't have any UCIe capable 3 nanometer parts out. So what's that about? Where's that going? And then
MI350.
Yeah, MI350 or MI400, one of the two.
Yeah.
But yeah.
Also, that number is crazy. 0.6. Yes. I keep wanting to say petajoules because that's too many. Picojoules.
Yeah, picojoules.
Okay, so you've got 10.5 terabits per second per millimeter. That's a density shoreline. But an academic paper after has double the speed for the same bandwidth in 28 nanometer.
My guess is that the one on top is double-ended.
Yeah, there are other features other than speed and density.
Yeah,
that you need. So after that, we have Cadence doing a UCIe in 3 nanometer FinFET with CoWoS.
It's half the shoreline bandwidth and half the power. So it's literally cut in half in terms of those two specs.
Yeah, I guess.
Funny.
Yeah, but it means you have a better granularity if that's your minimum irreducible. But this is per millimeter. This isn't, it doesn't tell you how many engines are in actually in the thing. And then Intel has an optical engine, 108 gigabit per second optical engine, which is at 0.9 picojoules per bit. We've seen companies with like 4 terabit solutions, but they're more in the 10 picojoule per bit. So there's that. And then Marvell is looking at the first 200 gig PAM4 retimer with integrated optical driver in 5 nanometer. So we'll see what happens there. And then on the last day, again, this is a educational day, so I don't know if we'll be able to go to it.
You did skip the 31.7, which is the IBM, which is the conflict, the IBM Telum 2 processor design technology co-optimization for power performance and reliability.
I mentioned it.
Yeah, but I really want to go there because what do they do for reliability? Because that's what Z is known for. Is they never go down, or if they do, it's like their uptime's insane. So what do they do for better reliability, right? In their co-optimization?
go watch my Jacoby interview from Hot Chips. We actually cover some of that. That may give you a sense. Because I did ask him about how do you design differently for reliability, and he went into a number of, I mean, admittedly high level things, but things you went, oh yeah, you actually should probably do that if you're doing reliability. So, yeah, and on this Thursday, again, it's a forum education day. Not sure if I'll be able to go. Only a few of these things looked interesting, but we've got NVIDIA talking about decoupled data. So whether that's an approach for their AI. Samsung talking about their memory solutions. That might just be a recap of their roadmap. Grok, I'm hoping, so this is from Igor, I think, who's their CTO. I'm hoping this is some insight into the next gen chip.
That would be nice.
Or it might just be what they're currently doing and it's nothing new. Then we have Intel optimizing communication for future silicon in package. Again, maybe a nod to Falcon. And then Todd Austin, who I think follows me on Twitter, is talking about security for chiplets. So we'll see. We'll see. DKR said Tom's came to the opposite conclusion based on the numbers I got. Interesting. So ISSCC, I have some discussion questions. Let's bring up this just so people are aware of what it is. Why does ISSCC matter?
Because it's a great conference if you want the nitty and the gritty of design and what goes into designing these chips, and like, as much as I was saying earlier that the C910 system has issues and all that, I understand how complex that system is. So, like, yes, I'm complaining about it from an end user perspective, but I understand just how complex and complicated, just how much has gone into just this very simple SoC.
So why would a company like Intel or AMD or Qualcomm or whatever, or why would they even present there? Surely they're giving away some trade secrets.
So Mr. Viptus, when will CNC bring a poster/slash presentation to a conference? Oh boy, that's.
I mean, to be honest, you could get Chester up there talking about C910, for example. But so it's one of the questions you think, well, yeah, why do they? And the whole thing is, it's part of this industry participation. Some of this stuff is already out. Some of this stuff is done. It's just research, and they're using it as an opportunity to, speak to peers about something that's non-supercritical and perhaps ping and bounce ideas off. And the whole idea is that everybody in the community participates. There's only one problem with that. Apple don't. Apple attends, but they do not present, which is really frustrating.
Yeah.
So, and then this is their validation of what they're working on. So what are we expecting from the event? Because it's doesn't it feel frustrating to sit for 4 days at a conference and only get a nugget of information or two?
Honestly, to me, I just get more excited.
Yeah.
Like, I just want to know more.
For me, it's finding, I've told this anecdote before. These are the conferences where I found out about backside power delivery 5 years before it became more mainstream. It's one of those deeper integrations into things like this that you then extrapolate out where exactly it wants to go. So it helps provide some context into what else we're seeing, and as George said, it provides a greater appreciation for the complexities of these things. People just think, oh, chip, add. How did company I or company A or company N screw this up? But you realize actually there's a lot in here, and we're not even talking about like silicon validation and stuff.
Yeah.
But it's also the people you speak to.
Yeah.
I've gotten work from attending these events. I've presented at these events. If any of you saw the video I did about my presentation for applied materials at IEDM, that was pretty cool. We got to speak about what's beyond 3D. There are some people you only meet at these events as well, and it's great to sync with them. So many companies that are worth talking about, I think, but you only find them at these sorts of events.
Yeah. So a massive thank you to Afifi.
Let's finish the discussion points before we get to that, because it's a slightly different topic.
True.
So another question: why don't other press or analysts go to events like this?
Do you want the PR reason or do you want the real reason?
Well, you do one, I'll do the other.
I guess real reason is for a lot of them, there's not a lot of content that they can pull out of it.
I was going to be a bit more direct than that.
Okay.
Most of our peers aren't engineers.
Yes. Well, I'm not an engineer. I've never claimed to be an engineer.
You're a physicist. You're a STEM.
Yeah, but I do at least try to understand this at some lower level, right? And I think that's why people like Mike Clark or
you want to sit and chat because Rohan just over time it's osmosis.
Yeah, well, not just that. It's if there's a press event and there's a whole bunch of press, well, who are those people going to hang out with when they have to be there? The people who can at least understand what they mean. Like,
yeah, it also means you can ask more detailed questions and you get that nugget of information. It's like, they said that because this must have happened.
Yes,
it's that sort of stuff. And yeah, I think we process the other side of it is how much does it cost to go? Yeah, it's I think if you want to just go to the paper sessions, it is something like 600, maybe 800. If you want to do the whole thing, it's 15. Or you go as press and it goes for free.
Yep. So there's one last thing. I remembered it, and N5 does use the same bit cell size for SRAM as what Intel's saying for 18A. It's 0.021 micron squared.
Yeah, so Dom on our back end has given us a table from an Antec, but from Anton.
That was actually me.
Oh, you did, yeah.
Yeah. But yeah.
So
yeah.
Let's go to this, and thank you for the €50, Afifi. It will pay for a dinner or ISSCC, no doubt. I vote the Thai place.
Yeah, more specifically, it's probably going to pay for my dinner at ISSCC.
No, it's whenever we go downtown San Francisco, there's a place called King of Noodle. King of Noodle Thai House. That's really, really good. I recommend everybody go. It's just off Union Square, I think, around 4th and 5th Street. So definitely pay for that. So let's go over these because there's a few questions here. In how many years do you think we'll see, one, the death of the hard drive, storage mostly on tape and SSD? Never.
Yeah, I was going to say never. So I don't know if you know Amazon or AWS's S3 storage. Oh God, I forget what subsection of S3 it is, but they actually have basically swappable. So you know how a CD changer works. Imagine that, but for hard drive platters. And the reason why they do that instead of tape is because over the long term, it's a lot cheaper for Amazon, because tape has to be climate controlled. Hard drives really don't. So they honestly don't need to. I don't actually see the death of hard drives, at least for the next, honestly, like
ever
25, 30 years at least.
And to be honest, Seagate and others are working on new technologies for higher density. We saw 32 terabyte drives at Supercomputing last year. Before that, we saw 30 terabyte drives. Things like dual actuator, hammer, all these technologies to improve density. Or if they're not improving density, they're making it cheaper. And what I showed you there, that was for 18 terabyte drives. I have another 20 up here. 20 drives, not 20 terabytes. I have another 18 drives up there. I have another, dozen over there. I have hard drives.
To move on to question number 2, x86 representing less than 75% of new PC sales. When you say that,
we're already there.
What do you mean by new PC sales? Do you mean PCs in terms of stuff that runs Windows on them? Because in which case,
no, usually we're talking about unit cost of computer, so unit market of computers, which right now is about 270 million units a year. Right, and I think Apple covers the most of the non-x86. Then we have Qualcomm bringing up a bit. RISC-V is nothing. And then we have homegrown stuff. So China and Russia. I'm not sure if they're factored into the 270 million.
They're going to be tiny.
No, I know. Well, you say that, but if they deploy a Chinese CPU into the Chinese government,
Xiaoxin.
Yeah.
Xiaoxin, which is x86. So.
Oh, that's x86. That's true.
Yeah.
What is Apple unit sales PC? So here it suggests that Apple does about 10 million a year. So out of let's just say 300 million, that's 6%.
Isn't that 3%?
Maybe.
Yeah, I think that's 3%. Yeah, it's
PC.
Honestly, you could frame it 15 different ways and get 15 different answers to this, in my opinion.
Yeah. MacBooks as a percentage versus desktops. That's a weird graph.
Also, unit versus sales value, value sales, because you're gonna see a lot of cheaper PCs are shipped, so
which is why sometimes people quote revenue rather than unit sales. So how many years? If it's still that low, then maybe more than you think.
Yeah. People forget just how many chips Intel ships. Like, Intel ships a lot of chips.
They still have 70+% of the notebook market.
Oh yeah, easy.
Yeah. Okay, so question 3: a good RISC-V compatible chip being widely available at retail.
When Tens Torrent Ascalon launches, in my opinion.
Widely available versus available, right? The Tens Torrent PCIe cards that you can buy today, yes, they're available. You can click on the website, buy it now, done. Are they widely available?
Let me put you this way. for reasons other than just development.
Mm-hmm.
So NaviJack says widely available to me means I can go buy it at Best Buy and get one. To me, widely available is I can go to Amazon or I can go to an online retailer and buy it. To me, that's widely available.
So basically, when an OEM, like a Dell, a HP, Lenovo, or even an MSI or a Gigabyte or an Asus, when they start selling one, how many years to that? Probably
that's
10
going to
plus.
be a while. 10 plus for them. Now, in terms of something you could go like buy in terms of like an SBC, which I
well, you can get SBCs now, but high performance.
So
hopefully within the next 2 years, and hopefully TensTorrent does buy it now on their website.
I suspect that for reasons other than just development, I think TensTorrent will have a SBC chip.
Well, they'll have a this.
Yeah. Who they partner with.
And the worry there is that if it is high performance, I wonder if they'll judge the sales right. Because there's a scenario I can see where they severely underestimate sales, but there's also a scenario where they overestimate sales. But they're probably not going to make 100,000.
No,
but likely they probably should make more than 5,000.
I think a good number is probably about 10. If they make 10 to 15.
It's so this HiFive, what does it retail for?
$400.
And the previous one was 666 for some reason.
Yes.
Because it is a small batch dev kit style, it does cost more than you would expect a high volume part to be.
But what's interesting is basically for the same thing, Milk-V is selling it for half the cost. So
yeah, but they may be. That's the thing. I wonder with the TensTorrent cards, like the ones I've got up here, the 75 and the E150, they're probably selling them near cost. They're not too worried about profit because it's a dev platform. So I don't know how close to the stone. And again, it also depends on who they partner with, whether they're going to have DDR memory or whether it's going to be LPDDR on board only, or whether it's going to be socketable, or whether it's going to have full PCIe support, and or what's the IO situation going to be. But something. And whether that'll be staggered, whether they'll do a small one and do a few thousand, and if that does well, let's do more. I don't know. I haven't spoken to them in a little bit. I need to go speak to them because they did just do a fundraise, which I still need to do a video on. But yeah, no, good questions, Afifi. Thank you. That's a well used super chat, and again, thank you for buying us dinner one evening at ISSCC.
Now, do you want to cover number 5, or do you want to get to the Furiosa news, because we did cover that a little bit?
Let's go straight to the Furiosa news.
Okay.
I will. So let's start with your article, and can you give us what we know about this company called Furiosa?
So actually, I think you probably know more about the company than I do. But the Furiosa is the Korean startup AI company. Oddly enough, quite a few Korean AI startup companies. I know you have a video with Sally on Korean AI startups. But this is their 2nd generation chip called Renegade. And if you can't tell, I'm pretty sure that the CEO is a big fan of Mad Max and that franchise. But yeah, this is their 2nd gen chip, which they showed at Hot Chips 2024. This uses 48 gigabytes of HBM3 that run, which gives a total of 1.5 terabytes per second of memory bandwidth. And this is very much designed for AI, first and foremost, for low precision operations, for
yeah, it's using advanced packaging. It's an AI inference chip. You know, and it's focused on LLMs, large language models, and basically it's an advanced card that's designed to compete against NVIDIA's inference chips at a lot better performance per watt. They're saying up to 3x, and it's technically it's a tensor contraction processor. So what they do is they're able to condense the mathematics of LLMs to improve the throughput. They have a special thing that they do that in hardware and on the compiler to do it. But they showed off this chip. They launched it, as George said, at Hot Chips 24.
Yeah, and
we saw it in person.
Here's the high level diagram of it.
It's and here's the they had 8 of these in the system.
And what's interesting, at least to me, is you sort of skipped it. Unfortunately, the image is a bit buggy, but whereas with GPUs and GPUs from AMD, NVIDIA, and Intel, what's known as the local data share. So if you remember that chart, the shared memory versus shared local memory, and for AMD, local data share, or LDS, those are all actually optimized for bandwidth. They're meant to push as much bandwidth to the GPU as is possible. However, what's interesting is that Furiosa actually optimized for capacity over bandwidth for their data memory, which is as close to a comparison to this sort of shishmem shared memory LDS as you can get.
So the chip's not the news.
No.
This is the news. They may be acquired by Meta. This came out, just as we were about to go live. So I wanted to talk about it. So the chip is TSMC 5 nanometer. They partnered with a chip design house to do it. The CEO says here, June Pike, previously worked at Samsung and AMD. And I'll just go through what it says as I go through my notes here. So the whole point about a startup is that you raise a bunch of money and you go design something, and you raise a bit more, you design it better, you raise a bit more, and then you go sell it. And then maybe you have some money left over to go design the next one. And the cycles, at some point you break the cycle by either doing an IPO or acquisition. And so as a result, startups have funding rounds. You have a seed funding round, then a Series A, then a Series B, then a Series C, then a Series D, and hopefully you don't get to Series G, H, I before something happens. Every time you go through a series, you get more money, but it dilutes the investment of your current investors. So as a result, while you're in startup mode, you have to make deals with companies, for purchases. But the first stage of that is signing deals to do proof of concepts. So Furiosa has signed deals to make proof of concepts with LG and Saudi Arabian oil. Over the years, the company has raised about $115 million. So that's since it exists. I think it started in 2017. Yeah, it says founded in 2017. There we go. So with these companies, you obviously look at the revenue and what we call the burn rate, how much money they're spending each year. So the revenue in 2023 was $2 million, which sounds low, but it's a startup. They don't break that out as to hardware versus services. Thing is, their burn rate, how much money they're spending, is about $40 million a year. So if you've only raised 115,
that's a high burn rate.
For that amount of money, it's a high burn rate. Thing is, their last big funding round was in 2021, which was a Series B for about 60 million. And they recently took, but what's weird is 2 weeks ago, they took a $1.4 million funding from an investor randomly, just out of cycle.
Okay, I don't know much about funding, but isn't there like Series C and then D and then E?
So you can have interim. You don't always. It doesn't have to be, full rounds. But the fact that it's only 1.4 million, which isn't a lot, means that either this was a favor to someone, or oh crap, we need some money to pay people.
Oh, you mean 2 billion won?
No, 2 million. 2 million. No, 2 billion won, or 1.4 million.
Okay, I thought it was 2 billion USD. I was like, wait, hold on.
No. I said 1.4 million USD. I'm just trying to work in USD to make it easy.
Yes. Okay.
My notes say one, but I've got USD in here.
Yeah.
So if you're letting an investor come in for 1.4 million, it means you got to pay somebody. Either that or you're doing something for somebody. So this is why this is coming. And Forbes have essentially said sources close to the matter say, right?
Oh. Okay.
So Forbes is reporting that Meta is in talks to acquire the company. Now, because of that funding, it kind of sounds almost dire if they're running out of money and their burn rate is that high. So you mentioned that there's a number of Korean startups out there who are doing stuff like this. I think there's like 7 or 8. We recently had 2 of them merge.
Yeah,
2 startups merge.
Yeah, Rebellions and Sapion merged, and I believe Rebellions is essentially who came out on top. Because
that finished 4 months ago.
Okay, because I know that Sapion. I didn't see Sapion at any events, but I did see Rebellion. Oh, okay. Because I did see Rebellions at Supercomputing 24, but I didn't see Sapion.
Yeah, I've seen Sapion a couple of times. I've got photos of their chip
since the merger.
Yeah. So, if Meta are in talks to buy a Korean AI chip startup, I've got some discussion points here. One, what the heck is happening with Korean startups?
Yeah.
If companies are needing to merge to stay afloat and taking $1.4 million to potentially stay afloat, wait, what?
Sapion was funded by SK. By SK, weren't they?
So this is the thing, right? There are 3 main sources of funding in Korea: Samsung, SK, or Korea Telecom. Right? And pretty much all the hardware companies in Korea are funded by at least 1, if not 2 of those. So it's all a big love-in anyway. Thing is, at the beginning of the year, Sally and I were talking about a trip to Korea with an agency was going to do a press tour of Korean AI. But that's essentially been canned, and we only learned of it being canned. There's been no update, and it was meant to happen in a couple of weeks. So doesn't look like it's going ahead. Now, the burn rate seems very high. Said 40 million a year for only 100 million funding. And I want to bring up this graph. And I need to explain it because it's kind of wrong, but it illustrates the point. That's why I'm using it. How much it costs to design a chip in a leading edge process node. Now, this is a graph from 2018 from who was the research? IBS. of how much money it costs to build a chip. The thing is, this money assumes a starting level of 0. As in, you have no people, no expertise, no IP, and you're starting from scratch. So yeah, if you're starting from scratch and you have no prior experience, then maybe it does cost 500 million, right, to go design a chip. Now, in this case, Furiosa used a design house. One of the big ones is GUC. The other one is called this Al chip as well. But there's also Broadcom and Marvell. AMD will do it for you. MediaTek will do it for you. That sort of thing. I only just realized it's Al chip and not AI chip because of freaking serifs. So yeah, 500 million for a 5 nanometer chip from nothing. If you're AMD, you have a ton of 7, 5, and nanometer experience, and 4 now, and so the costs aren't going to be all this every time. You've already got licenses for the software. You already have physical IP. You already have verification in place. So it's not all of this. The same report said 3 nanometer would be 1 billion or 1.5 billion. So is the cost of building a chip too high now for a startup, or do they have to leverage more of the ecosystem to do it?
Yeah, I would agree that they do have to leverage GUC and other design partners to make a chip, because it is quite expensive.
Another talking point here is they're presenting at ISSCC next week.
Yeah.
They're one of the invited talks. Will we see them?
Yeah, or will they disappear like Pat did?
Yeah, and the other thing I want to point out is, these companies do go through Series A, Series B, Series C, and a few of my clients have gone through Series D rounds recently. Their last big raise was a Series B, but that was in 21.
Yeah.
Did they wait too long for a Series C?
That would seem weird to me. Like,
well, maybe they tried to do a Series C and they didn't. Nobody bit.
I mean, I'm surprised that LG wouldn't buy at a Series C.
Well, I mean, maybe they would, but not to the. So, Series C for companies that are raising this amount is probably 100 mil, which would double their investment total. So if nobody, maybe it's just because of the fact that they're Korean, and people like Google or Nvidia or Intel Capital and some of the funds don't want to get involved. Don't know. And another point is, why would Meta want them? And the only answer I could think of is their internal chip design isn't going too well.
Yeah.
So MTIA, which I think is an Andes RISC-V core based design anyway. I don't know. Okay, let's. I'm gonna go to the controversial topic.
I was gonna say, do you want to do number 8 since we're on AI?
No, we'll save that.
I don't want to do number 5 though.
Well, let's go through it quick.
Okay.
Your vice president, JD Vance, yours, yes, yours, has made a comment at the French AI summit saying that the AI chips that the US will use will be designed and built in the US. This is to ensure economic innovation, job creation, national security, free expression, and beyond. To restrict its development now will not only unfairly benefit incumbents in the space, but also mean paralyzing one of the most promising technologies we have seen in generations, he said, while not speaking about China. And Barron's here, where our source is, basically saying 90% of the world's most advanced chips are made in Taiwan. But some of it is in Arizona.
Okay, I actually have to question that 90% figure.
No, it's 85, whatever. So, but the point is, there seems to be a push towards, this is the whole building more in America sort of thing. And the thing is, if we do a search for the Intel stock price, it's gone up today, 6%, which is good for Intel. If you look at the 5-day, it went up yesterday, it's gone up today. Look at the 1 month, it's still up, but
yeah,
up. So yeah, and I wanted to bring this up because people looked at the share price and went, "Oh, let's buy more of Intel," because if we're building AI chips in America, surely that means Intel's going to be where we're building them. And that brings on to my discussion point. Is Intel the right play here? Is there someone other than Intel that could participate? We know that TSMC is building in Arizona, Samsung is building in Texas, in Austin. Does it when I say American designed, American built, are they restricting it from non-US companies but that have US operations?
Let me put it this way. I don't even want to try to guess what that could potentially mean, because I don't even want to know. Like, I do not even want to get into that headspace. Let me put you that way.
Okay. That's because, okay, what about HBM, for example? There's no HBM manufacturing in the US.
No.
Micron makes all their Micron, which would be what you'd think.
Yeah.
All their HBM is actually built in Singapore.
Yeah. It's all in Singapore.
They are building a fab in the US to do it.
Yeah, they're building actually a massive one in New York right now. It honestly makes the Intel campus in Arizona look small in terms of the sheer square footage that they're building. But yeah, you would think Micron, and Micron is building up. So is Samsung. But currently there's no HBM manufacturing here in the US.
So if this was just Intel for a second and Intel products, I mean, so Intel has Gaudi 2, Gaudi 3, made at TSMC.
And then they have nothing.
And then Falcon Shores that just got made test chip. So is this a comment about Jaguar Shores, the 27 product? Or 26 or whatever it may be pulled in?
I mean, what nodes are going to be made at TSMC Arizona?
18A, P552.
No. TSMC Arizona.
Oh, 4.3, I think.
If they do 3, I don't know where advanced packaging is done, but if they can do 3, that in theory
Korea.
Maybe okay.
Because we don't talk much about Samsung's advanced packaging, but I think they have H Cube and X Cube, which is like their EMIB and Foveros and CoWoS equivalents. Perhaps that's worth a video in of itself.
Yeah, because we don't hear much about advanced packaging from Samsung. But no, I meant TSMC's packaging.
Oh yeah, no, that's all done in Taiwan.
Is there any building out of advanced packaging? Nope.
I asked this to one of their executives in my last interview with them, middle of last year, and there are no plans for packaging build out in the States.
Ironically enough, leaves global foundries.
Well, no, so Intel's got advanced packaging.
Yes, but actually, in terms of packaging done here in the US, actually, I think it's global foundries, because they were actually doing front-to-front hybrid bonding in 22, 21.
At volume? Or just
I think it was prototype, but it was like, yeah. So
yeah, Intel does its advanced packaging in New Mexico.
yes.
Yeah, so Intel for advanced
but they've hit packaging issues. So
that's more of a So what's my other comment here? So in terms of like the share price, should we care that the share price bumped up 6% on this news?
I don't understand Wall Street, so I cannot comment.
Yeah. Okay, general comment. Yeah, regardless of what you think about administration, how realistic is the statement? Is it just grandstanding, or does it have teeth?
Depends.
If
I think the answer to that is it depends.
It's probably 80% grandstanding, but there's 20% of me that goes, that should be a goal.
I think so. I actually think it's a goal. Like, unironically, I think geopolitically, I think it is a goal for the United States.
But given given the nature of the current administration, there isn't a reluctance to provide support unless it's a national security thing. But then
you could argue that this is national security.
Yeah, but then Intel effectively becomes an arm of the, we're saying who's going to acquire Intel? Well, the US government, clearly, if they're going to do that.
I mean, no, the US government doesn't really own companies.
No, I know, but it's like a Lockheed Martin, right? Or an equivalent.
But Lockheed Martin is the closest thing you could say is it would be like an Amtrak.
I don't know. It's
like also there is this. So
Skip
to sort of continue about this a little bit. There is talks about a U.S. sovereign wealth fund, whatever the heck that means, which may play a role in this somehow.
Well, it's sovereign wealth fund. It's just like the Saudi sovereign wealth fund. It's a bunch of money that the government puts up to what are technically now government employees to go and invest like a regular any other investment fund. But the whole point is bringing return for the government rather than individual shareholders. So the beneficiary is the treasury, not an individual.
Yeah,
which is fine. But
yeah, like I don't fundamentally have a problem with the sovereign wealth fund. It seems weird, but I'll leave that whole discussion off to the left side and
yeah.
Let's leave this topic because I don't want to be here no more.
Okay, we'll go to this one. Just because, yeah, this may be our last one.
Okay.
So, Nokia announces a new CEO called Justin Hotard. And if you're thinking Nokia still exists, yes.
Yes.
They're essentially simply an Ericsson competitor now in telco. Is it still Nokia Bell Labs? Is that still a thing?
Yes, it's still yeah.
So it's basically R&D for it's more focused now towards telco and everything else. The reason we bring this up is because you may not have heard the name Justin Hotard before. And it's more, we're bringing him up more because of what he used to do rather than what he's going to. So Justin Hotard used to be in charge of Intel's data center and AI group. And if you're thinking, wait, why? I didn't know that was a thing. I hadn't heard the name before. What was he doing at Intel? He was only at Intel for a year. His position was announced February of 24, and this announcement is made, essentially a year to the day, almost a year to the day. This role changeover is essentially April, but you can imagine he's probably already signed out of all of his Intel things.
Mm-hmm.
No statement from Intel has been made as of yet, because this is literally happening today. His name, he's already been scrubbed from the Intel website, as far as I can tell.
That was quick.
No, so the link still exists on Google, but when you click it, it just goes to a generic Intel page. As a redirect.
That's.
So yeah, it's one. Intel's now lost another person that's quite high up. Two, what the hell was he doing anyway? Is another question, because I don't think even with my relationship with Intel, I don't think I ever directly spoke to him at any point or got a presentation from him or was briefed by him. And you're thinking the head of the data center AI group, surely he speaks to journalists at some point. Speaks to analysts especially.
So, okay, Justin Hotard actually did host an event that you were not at. Granite Rapids launch, Xeon 6.
Yeah, that would have been it.
He hosted that and he ran it.
Okay.
So
that was what?
No.
When was that? October, November, September? Okay. Yeah, I think I had a conflict or something.
So
but aside from that, no. So just to give a background here, he does have a bachelor's in EE from MIT, so he is an engineer.
Mm-hmm.
He spent 8 years at HPE, Hewlett Packard Enterprise, as part of their data center division, and then he spent a year at Intel. And I have a few discussion questions here. One, was he ever press facing? Where you just answered that the one time. What happened the year he was there? Well, Xeon 6 launched, the rebrand to Xeon 6. But I think importantly, sales fell.
Yeah.
Data center is less than half the size of CCG now in terms of revenue. And Intel's whole thing was meant to be 50-50, but now it's
70-30.
Yeah.
Or like 60-30.
So is there any lasting impact to the fact that he's gone? I don't know. Because we don't really know what he did.
I think the answer to that is going to be not an answer that any of us can answer right now, or probably ever really will be able to. But what does this mean for the politics within Intel?
Well, we don't know whose side he was on, whether he was on Pat's or the boards, or with MJ or whoever. So okay. Now there's a position open, head of data center and AI. What does Intel need in that position? And you can't say Forrest Norrod.
Lisa Su. No. So
I got the feeling that Justin was more of a sales, even though he was an engineer. He spent most of his time on the customer-facing side of everything because of his relationship, because of his former position in HP.
So I keep saying he, but no, the person that replaces Justin needs to be good with the press. They need to know what they're talking about.
Justin had a little bit of riz.
Yeah. And that's sort of what I'm talking about here. But they also need, and this word gets tossed around so much that it almost has no meaning, but they need a visionary.
They need somebody with a focused strategy, not only in CPU, but also in AI.
Yes.
But okay. But they also need somebody who can bring the sales back up. Surely they need a sales-focused person.
Well, yeah, they need, like you said, they need Forrest Norrod. Yeah, but
it's Pat for DCAI. No, I don't think he's going back.
No.
At this point. Yeah, Karen Segal is going to be the interim replacement. Karen's been at Intel. I think she's been there 20
18
plus
years.
years. Yeah.
18-year veteran.
So, Mr. Vincent says DCAI has no upcoming products for a year or two.
Yes.
Xeon Sticks still has a lot of stuff to launch.
Intel has said publicly that GNR SP, so the mainstream versions of Granite Rapids, are launching this.
Yeah.
I believe this quarter, this half of this year. And Sapphire Rapids AP, so the full 288 core chip, also I believe is supposed to be launching with this.
You also have to deal with the ramp of Clearwater.
Also, Granite Rapids D, so Xeon D, which was covered in ISSCC.
Yeah. It's one of these things. You want Intel somebody to come in to simplify the portfolio and be focused enough that they can also grab it by the horns and run with it.
So unfortunately, and this is why I say they need a visionary. They need somebody that can actually see what is good and what isn't. I suspect that if they want to simplify the portfolio, the E-core Xeons are going to die. Because MJ herself said that there
needs to be focus.
Well, not just that they're struggling to find customers, essentially. Like, that the uptake has not been as fast as they were expecting.
Well, they're trying to pitch it again to the cloud service providers, but all the cloud service providers have gone and built their own ARM chips.
Yeah.
So,
which then begs the question, what happens with the E-core Xeons? And I think the sad reality is it's probably going to die.
Then again, I've come to the conclusion that at some point maybe Intel should just ditch their data center AI business, refocus, and then go acquire something later down the line.
I said that the whole Falcon Shores, Jaguar Shores project at this point should just be canned, because it's you're throwing good money after bad at this point.
Well, this is the thing, right?
I made that comment last time.
Right. The justification for going down the E-core route was because they can do E-cores for consumer and E-cores for enterprise, right? With Gaudi, there was no consumer equivalent. Movidius is a completely different architecture.
Yep.
And then with Falcon Shores, it was meant to be a mixture of XE and AI and HBM and then CPU, or Jaguar. Yeah, it's maybe even though data center is smaller revenue, maybe it's just too big. So because we brought up Forrest Norrod, he's not the head of AMD's data center division.
No, I don't remember who that is.
He is the general. He is the EVP and general manager of the data center solutions.
Which, if I remember correctly, is basically end user, like building out like a server with Supermicro or Lenovo or right.
Yeah,
an OEM.
It's funny. I searched for Forrest Norrod, and my picture with him comes up third. AMD head of data center.
Well, do they have is that Dan McNamara?
Yeah.
Okay, so it is Dan. He's sales.
He's server business unit.
Okay.
Then you have Vance, who's head of AI. Okay, Forrest is in a weird position because he's executive vice president. he technically sits above the senior vice presidents.
So he's, even though he doesn't have the full title, he's essentially head of server for AMD.
There's general manager of server business, and there's general manager of data center solutions. So Forrest is in charge of the AI GPUs, and Dan is in charge of the CPUs.
Okay.
That sort of thing.
Okay.
There's
but what you're saying is maybe DCAI needs to be split up into CPU and GPU, or CPU, traditional compute and accelerator. I'll say that.
Yeah, something like that. It's you know, Intel, they don't give much visibility into the org chart.
Yeah.
So maybe they already do that. We just don't know because it's under the person we speak to. It's under Justin.
Maybe, but to manage, even to have a single person at the top of an organization that big, like we were talking about who could replace Pat as CEO, because Intel's massive. Well, I mean, this is sort of just a smaller microcosm of that, right?
Yeah. I don't know. Intel, you need people. I don't know what to tell you. Well, with that, we've been going almost 3 hours on the main show. Not a record, but I know you've been yawning, and we've had some, you answer questions in the chat.
I'm almost out of coffee.
Yeah, no, my tea finished over an hour ago, and it's time to get some dinner.
Lunch.
Yeah, as Radix Griffin says, finding people is the hardest part.
It is.
Yeah, even with my business, trying to find people to fill in spots, it is difficult. And Dragon Balls again. Thank you for the $5. Is GlobalFoundries 12 FDX a technological dead end? It looks impressive, but no customers. Is there a place for FDSOI nodes at the leading edge? So 12 FDX technically hasn't been productized yet. 22 FDX is getting a lot of attention because when I interviewed Tom Caulfield in mid-23, I did ask, I said, you've had 12 FDX on your roadmap for years. Why isn't it available yet? And I think at that point, it'd been on the roadmap at least 5 years.
Yeah.
And he said, it's all about releasing the right technology for the right time. So if there's no customers, you don't release it. The question is, how much do you still work on it? The thing is, GlobalFoundries is what, $1 billion in free cash flow a year now. So and all the research they're doing on 22 FDX is probably transferable in some part to 12. The question is it the right price at the right time? So, is there a place for FDSOI nodes on the leading edge? Probably. You just got to find the right application. It might be one of those things that once it hits volume and the price comes down, it becomes worth it to a wider audience. But until somebody takes the plunge at the high cost at the beginning, and it's the sort of market that was way too sensitive to that cost to need it, or just doesn't need the performance. I mean, they do a thing with 22 FDX called body bias, where you can essentially improve the performance by reduce it, or you reduce the power by you improve the performance by near your transistor applying a voltage source to make it easier for the electrons to flow. It's something weird like that.
Interesting.
You induce an electric field, basically, and the electric field makes it easier for electrons to flow.
No, that makes sense.
So,
but also very interesting.
It's something that they did a while ago. But yeah, I'm pretty sure that's the. So is it a technical dead end? It's hard to say. They still talk about it. They still talk about it again at the right time. You're not going to release when we, Apple Samsung Foundry, for example, announces nodes that have no customers, like 3GAE never did. Whereas Global Foundries is a bit more conservative for that. So, and yeah, in development, there's IMEC has a 7 nanometer FDSOI node. That they've spoken about that before. Yeah. But yeah.
So you want to move on to the Q&A?
No, I want to go eat. It's time for dinner. It's time for dinner. So we've been going on for a while.
Yeah.
But we have covered a lot, and like I say, next week we're both at ISSCC, so we're going to have a live show there. Like I say, we need to go ping the PC World guys, see if we can use their studio for it. But should be good. We went through the talks, and I'm looking forward to it.
Actually, if I could just answer just one of the questions.
Yeah.
Real quick. So Miss Solid Reactor says, would AMD use UCIe to replace some of the external communication that is designed with Infinity Fabric? If I'm not misunderstanding at all, does that mean that AMD is enabling multi-vendor chiplet solutions? So what this is a UCIe PHY. They aren't necessarily using the UCIe protocol. So they could use the GMI protocol over a UCIe PHY.
So it's physics, not data.
Yes, it's the physical design, not the data protocol movement.
Yeah.
So, yeah.
Yeah. It's just the electrics, not the language.
Basically.
Electrics, not language. There you go. There's a t-shirt idea. For the merch store again.
Yeah.
Shop.techtechpotato.com if you want stickers. Yeah. So thank you all for attending this episode, and we'll see you next week, I guess. I've been Ian from TechTechPotato.
And I've been George from Chips and Cheese.
Have a good one.
Have a good one, y'all.
I took your thing.